Those that are daring, brave, and adventurous, right? Boldly go where no one else has gone before.
Yeah. I think it's hello, hello, hello. Welcome. Can you hear me?
We need to speed up, guys.
Yes.
Ah. Where's the slideshow? Oh. Yeah, thank you so much for hacking away. We're really excited for your presentations. We're running a tight ship today. So I will sit over there. I have a sign that says 1 minute to go. I'll say it once for when you're presenting and once when the jury time is also over. You have a 1 minute transition time out, and then the next team has a 1 minute transition time to set up. You have 1 minute to say something.
1 minute to say something. First of all, I mean, it's really exciting. I mean, to see, what you have done during the weekend. We can't wait to see your presentation. And as Lisa said, we are running a very, very tight schedule. There are 17 presentations, 17 teams that are going to present, which I think is one of the biggest numbers of teams we ever had. So the first team, Lisa, to present, who's that? The first team is Urban Eyes. If you can come up, Urban Eyes, come up and prepare your presentation and your computer. So, anything else? Only one who can ask questions are the jury members. The juries are Timo Lehtinen from Kira Hub in Finland, Darshini Momka from Blocks Hub, and it's Martin Tamke from Danish Institute of CISA, yeah. So welcome to them also. And the last thing, we also want, already now to thank our partners and sponsors, because without them and their, support of the event, it would be impossible. So give them a round of applause also. Are you ready?
Actually, if I may.
No, sorry. No, there's some unfinished business.
That's right.
We never give up.
That's right. So I will be less than a minute, but we'll make this quick. So just to go over everything again, make sure you introduce very quickly who you are, what was the problem you were looking to solve, how you did it, what you would like to do, challenges you run into, all of that kind of thing. Before we get started, though, because Blocks Hub is very much about not leaving as is AEC Hackathon, any business unfinished. I would like to invite a winner last year up to the front to receive his chocolate that he did not get. So it is with great pleasure, if we may, give a round of applause to Simeon, the winner last year. Woo! And with that, the floor is yours.
Thank you. Okay, awesome. Hi, everyone. Good afternoon. We are Urbanize. So, what problem did we solve this weekend? Well, in a nutshell, we tried to solve the socio-fabric of Copenhagen. And how did we do that? Well, before we get into it, of course, who we are. I am Chavasha. I'm a machine learning engineer, along with my co-founder, Vinayak, who is an architect and a super amazing developer. Then.
Well, there's a well-established problem that we have a lot of data, but it's so fragmented that when we have to do anything with it, the process is so broken and it's really annoying. Whether you are an architect or a real estate developer or anyone looking for a new place. So how did we fix it? Well, we fixed it with Urbanize, and we're going to talk about it. Well, throughout the weekend, we collected a lot of different data sets, which my partner is going to talk about.
Well, talking about the data sets, we collected I might be wrong on the pronunciation, please don't come at me for that, but Trich-Fonden survey, which is basically a perceived safety survey for Denmark. Then we use the Denmark Status API, which is the crime API. Then, of course, Perplexity Live, Web News, Google Cloud API, and the Dava API.
And taking all these different data sets, we initially broke down our work into two parts: proximity analysis and social fabric mapping of Copenhagen. So we're going to walk through the whole process in just like 2 minutes. And we took up these two different parts. We pitched it together in the hackathon, and hopefully we push it into production by Monday. But before all this, what did we have before we came here? Well, we had a very well-functioning platform in which you can select any site globally, and we will give you a lot of different maps in 2D, 3D, a lot of different data sets coming in together, land use pattern, population patterns, accessibility, a very quantified breakage of numbers and data sources together, and a very cohesive way of presentation of environmental report. But on top of it, what did we do this weekend? Well, first, a working demo of the product. We added customization feature to the quantitative metrics. So based on different offices and their own color schemes and patterns, you can customize it, download it as SVG PNG. We mapped out the social fabric proximity of Copenhagen. So you have all these different visualizations trying to capture different engagements. This is a street use map which shows vehicular and non-vehicular movement and how people are moving, where people are moving, transit stops, and how all these different fundamental layers kind of come in together, which is pretty important while designing on a urban or a site level scale. And what are the cultural hotspots in and around, and how is it affecting the transit and the mobility around your site? And moving forward, of course, there's a specific map for just transit, so you can understand things in isolation, but also overlay it with different maps together. And towards the end, a proper scoring system which takes all these 7 to 8 different maps together and scores different pockets of the neighborhood of how socially integrated those pockets are.
Next, we worked on another feature, which is called the proximity analysis. So on the basis of your business category and what you're looking for example, you want to look around cafes or bakeries around your site, then you can quickly do that. Now, the interesting part is we had a safety overlay. So it's already analyzing. What it does is that on the basis of your site, it tells you the safety score. We have used the data sets that I already mentioned before. And this is the community engagement part that you can also verify whether you agree with the safety score or not. And it also gives you the safest, shortest route to what you're looking for. Next, we have an urban buddy where you can ask it information regarding the proximity analysis feature. For example, give me top 5 cafes near my site. It does that. And then you can also be clever with the prompting. Like, I have a 5-year-old and I want to take him for his dental visit. Now focus here on the business category. It automatically switched it to healthcare, dentist, and it gave you the answers. Now, closest one. Now, of course, this is not GPT, so you can't ask it, how are you doing? It's not going to answer that because we've restricted it to be only specific to what you're looking for. And then again, being clever with what you want, and it automatically switches to education and entertainment, cinema and theater, and gives you all the information.
Well, what were the technical challenges that we faced while building this whole thing up? All the different data sets that we had to work with. They come in different languages, they come in different form structures, so to put them together was quite a fight. And on top of it, are we automating anything, or are we talking about machine learning integration into it? Well, we are. My partner is going to talk a bit more about it.
So when we talk about machine learning and AI, we didn't just want to plug it in for the sake of it, right? We want to make sure that we're not just using a generative LLM to give you our responses. So we're doing a heuristic-based approach. We're giving you answers on the basis of the data that we already have.
And moving forward, we also automated a lot of different maps, and we automated that you can change the quantitative cards that you get into different graphs. So based on however you want to use it in your own practice, you can. And are we scalable? Well, we are. Our Urbanize as an application is already being used in 75 plus countries. We have an ever-growing user base, and along with that, an ever-growing data bank. But in this weekend, the first thing that we did is that Copenhagen was the first city-specific integration that we went with. And moving forward, that's what we want to do. But do we integrate with your workflow? Well, we do. You can export our maps and our data structures in all these different formats, along with SVG, along with Excel, Power BI, and whatever your industrial need is. Community engagement, again, going back to Chavish.
Now, as we mentioned in the proximity analysis, we had the community verification feature. So the idea is that based on if you agree with the score or not, it goes back to our algorithm and it gives you a better response the next time you show up. Now, the idea is that we can collaborate with municipalities so they can directly take this data to make an informed community decision, or they can also give their own knowledge to our database.
But what's next for us? Well, wait. The next step for us is to scale up and integrate with more countries and more cities to become the best location intelligence tool and to make data equally accessible for all the stakeholders, including people in the community. In order to do that, we need money, we need to work hard, and we need the support of AEC community. So thank you for that. Yeah.
And do you hear me? Yes, okay.
Yeah.
Maybe I'm not switched on, I guess so. But what is that you talk about social? But like, so what data do you have besides traffic and so on? And then you talk about community. How do you engage community, or how do you create community? What is your plan?
Yeah. So we took a lot of already available stats from the links that were shared with us. We integrated those data points. And when we talk about community, essentially what we mean to say is that, let's say in proximity analysis, somebody goes and searches for what are the safe places, like a safe cafeteria to go or a nearby clinic to go. What essentially happens is that there's a lot of Google reviews about it on already available. So we scrap that information. There's a lot of safety metrics that Copenhagen municipality has already shared for different neighborhoods about what communities are feeling over there. And then we overlay all those informations together. And on top of it, we allow people to vote while they are searching. So do they find this result to be accurate or not? If they say yes or no, it goes back into our system, and then we further train our model on top of it.
Okay, yeah. I have a question about, you mentioned about the data and the main different data sources that you get. So what were the data challenges that you faced during the weekend?
Yeah.
Not the basic product, but if any challenges that you met during the weekend, and what have you done to standardize it?
Awesome, thank you. So, of course, with data sets, the issue is that they come in different formats. They don't come in a standardized, like if you want XYZ column to match with another XYZ column, that never happens because they're all coming from different sources. So one biggest challenge that we had is to make sure that all of the data that we get, we define our own metrics so that the data can match together. So this was one of the challenges definitely that we faced throughout this weekend. And sorry, what was the next part?
What did you do to standardize it?
So we, of course, set up our own certain rules. Again, I go back to like a heuristic part where I set up my own, like our own rules, how to handle the data. And of course, if you have a data set with 1 million of rows, not the entirety of the data is going to be useful. So you also need to make sure which column, which feature is useful. So I also did dimensionality reduction for that. So to make sure that the data comes clean to us, it's usable to us, and it's also not a lot to grab at once. So.
And do you need ML engineer or a data scientist to do this all, or is it, how much usable is it by another stakeholder in the AECO?
Right. So as a product, I don't think you need an ML engineer to use this because it's pretty straightforward. You see the data, you do the click, and if you need to navigate, we also have the urban buddy thing that we introduced. But again, yeah, I don't think in today's age you need to specify that only an engineer can do this because again, we're all like a different community here. Everybody can technically use the product easily.
Okay, next time we go from left to right.
Yeah.
Alex, if you stand on the other side, I can take care of the computer.
People to see the screen.
I'm going to stand here and advance the slides.
If you talk, I can advance the slides.
No, I need to do it at the same time.
And I prefer you to. I'm not confident.
All right, everyone. We are Clash Hero. I'm Alexander. This is Bruno, Andreas, Simeon, and Christian. And we'll start by just saying, what is clash detection for those of you who are not deep in the BIM world? This is a collision between models from different disciplines. So you might have a structural discipline. You can see some beams here, and an MEP discipline. And basically the ventilation ducts are colliding with the structure. So what do we do? How do we resolve these clash detections? This is the problem we are trying to solve. And within some companies, there can be 10,000 employees, but only a team of 50 people who have the sophisticated expertise that's needed to handle these collisions because it's complex. There's a lot going on. So what we want to do is broaden that base. Sorry, we want to broaden the base of people who are capable of interacting with these clash decisions and increase the number of people who can help to resolve them. So if we look at how data is hosted today, there's often a common data environment within Dalux, but we're actually really focusing on this point where each of the disciplines is uploading their Revit model to Solibri, where those clashes are detected, and then those are communicated to the rest of the team through oftentimes BIM Collab, but it could be many tools. And what these reports look like now, just so you understand what we're trying to improve, is they can be these very long documents, and all you get is that image of what is the clash, and then you have to resolve what is this? What is the context? Who's responsible? And you can get 40,000 of these. So it can be really overwhelming. And we're targeting that space with Clash Hero. So that process without Clash Hero can be quite manual, where a BIM coordinator has to import everything. There's 40,000 clashes. They have to find a bunch of rules for filtering that. Then they run the filters, and they might bring it down to 5,000 rules. They review it all. Then you get 200 issues that you're sending out to the different disciplines, and then you assign those manually to everybody. Tell them, hey, here's this collaboration file. Please fix it. And then you repeat this process until there are no more clashes, and you can build the building. What we are looking to do is to automate many of those steps and really streamline it using an LLM. So the BIM coordinator would open up the Clash Hero agent on their desktop. The agent then federates the model, deals with those 40,000 clashes. That BIM coordinator can then discuss the rules for filtering, and the fact that you have skills and memory and storage means you can start to predict some of the rules that might be relevant on this project and carry experience from one project to the next. The agent runs that clash detection engine. The agent helps prioritize filters and create the clash issues, creates a report that the BIM coordinator can then review, export it, and then the process proceeds as normal. Whew. Here's our software diagram from the very beginning of the hackathon, right down memory lane. Wasn't that fun? What we're focusing on is Clash Hero is to, you have a BIM manager, and they have their IFC, which is their BIM model. And it's exactly this connection between the model context protocol, which is how natural language can then interact with this system of running the clash engines and developing the rules and filtering it. Okay, doing good on time. So how did we do this? Here's our tech stack. Claude MCP, Model Context Protocol, is in the middle. So it's essentially a bridge between the natural language that you enter in a chat and very specific commands that are relevant for clash detection. Here you have the user side interface. So Claude Desktop is how you interact with this. The disciplines will have their IFC files that they've prepared. That is like the structural beams, the ventilation ducts, etc. And you can view the output from Claude and Clash Hero in a web app, which we'll show you. Then on the back end, we've built this weekend a Clash command line interface for handling the clashes that interacts very closely with this BIM coordination file, which is what is sent out and communicated to everyone. And we have also a database side built on SQL. And now I'll just show you one example here of kind of when you look into this on the back end. So the Claude model context file kind of runs the clash detection through this command line interface that's built in Rust. And all of these are different tools that we made that kind of become accessible to the person who is chatting with Claude. And so here you see an example of what it looks like to chat. I'm going to let Andreas narrate this.
Sure. So here we're just talking to Claude, and I ask it to run a class detection of the IFC files I have on my computer. Claude knows where to look through some of the tools we implemented in the MCP. So it's going to find those files, and it's going to register those files that we want to run the clash detection on. So here we've actually been working a bit with it, so it remembered what we did last time. So here we ask it to run the clash detection on this arch, HVAC, and structural model, and it does so. And we can set up rules, but it also have the rules from the last time we ran this, so it just runs with the same rules as last time, but you can just chat with Claude and change those rules. And then basically you can run the clash detection and open the BCF in our web app here.
And isn't that web app nicer than a million single images? I'm going to hand this over to Bruno to navigate the web app that we built.
So you can see the different clashes in a visual bubble. You can interact with the viewer, select with different colors, and see on the IFC models the different clashes. You can select specifically which clash you want to see, and it isolates the clash on the IFC model. You can reassign them. You can comment on them. So you say to your colleagues that you're going to fix it next Monday, for example, and you can reassign the different clashes. Sorry.
And we hand it over to you, the judges. Just say, check it out. It's open source. It's on GitHub. Thanks, guys.
All right. Good job. I really like the idea. I've actually never understood why we need BIM coordinators in our projects anyway, because the tool should be able to handle that. But yeah. But yeah, this is one step towards that future. I already forgot my question. What was you seem to do quite a lot of work over this weekend. What was the kind of biggest challenge you face, and how did you solve it with this project?
I think we were actually in the beginning quite good in kind of delegating different tasks. So I worked on the CLI, Bruno was more on the web app that we saw in the end, and the other guys kind of tried to tie it all together. So I think if you ask, we all had our own big challenge that we kind of solved. I don't think there was something bigger than something else, like it was all kind of broken down in some silos, and but it worked out.
I think you're being a bit modest, Christian, but I think Bruno has some experience with clash detection, but the rest of us haven't really had that experience. So Christian threw himself into implementing this clash detection engine in Rust, which gave a bit of friction in the beginning, but you ironed that out. So yeah, that was pretty cool, and we could kind of connect all these things with the MCP, which I hadn't tried before. And it's really intuitive and easy to work with. So yeah.
Yeah.
Good job.
Good. Yeah, I can I can take the question. So it looks really cool, and also usability-wise, it looks friendly for non-technical users. I want to know that what testing have you done to see that it will be usable on a Monday?
Like we didn't have a lot of sample files, but we did run it on several IFC files that we got the clashes out of.
Okay,
but
yeah.
So it's still simple, but like it's working.
But is it something that you knew that this is a clash in the past? Is that the data? Like, did you label it, or or is it the LLM that decided it?
Yeah, no, there is. So the LLM is getting all the clashes and return all the clashes to the database. It's just helping you to filter and prioritize them for you and assign them for you and get this context of issues.
Okay, and is there a matrix that you have put to show the coloring? Yeah, no worries. That's good, yes.
Thanks so much.
Yeah.
Isn't the real problem then to help the poor person to solve this kind of?
To solve this one?
If you have like 10,000 clashes,
Yeah,
then
exactly,
isn't it a very
yeah.
good problem? So
Yeah.
how do you solve it then? Like, what do you prioritize?
Technical understanding that the clashes are discovered when the models are uploaded.
Yeah.
So it's like intersecting a bunch of things that shouldn't be overlapping.
I do not have a HDMI from you.
I think for you the USB-C.
Got it working or? Exactly. Perfect. Get some visuals.
Perfect. Right. Hello, thank you. I'm George. I'm a environmental sort of consultant here at Blocks Hub. With me is Boy, an architect and our resident BIM expert, and also Jonas, also an architect and also a great sort of coder and contributor in all of this. So what we are going to do is we're going to talk about how we can improve the access and visibility of biodiversity in our urban spaces. Because the way we see it, biodiversity is sexy. I think we all know it's sexy, it's great, but people don't tend to pay much attention to it. It's not very visible on the day-to-day basis. So what we wanted to do is we wanted to make something not for urban planners, not for designers, not for engineers, something for the people out there in the general public. So this is about being very available and accessible, and for that reason, it's a simple tool to visualize what our cities could look like with more biodiversity in it. So our goal is to help the public understand and see where biodiversity can come into their regular lives. I think a lot of people realize that biodiversity is important. This is a crisis that we are facing at a global level now. It's a pillar of the sustainability and of the resilience that our cities require. And if we don't have biodiversity, a whole cascade of additional problems can befall us. So with that, I'm going to actually hand over now to Jonas, who will go through a pre-recorded demonstration.
So yeah, biodiversity is sexy. This is really our motto. It's quite on the nose, but the thing is, well, we figured biodiversity, the way it is discussed, this is like a huge, somewhat abstract term for many people, and they think about, like, developers tend to think about cost when we talk about that biodiversity, right? I think a lot of people think about restrictions when they hear biodiversity laws that are in place, but we really want to shift this narrative a little bit, this focus, and show what this also could look like if we plan with more biodiversity in mind, and to shift the narrative a little bit to show what there's actually to gain for us. And so we created a web app that is also available on the phone. The idea is everyone. This is not just for us as industry specialists here in this room talking to each other. Now we want to engage the people out there again that we all always pretend to be working for, and bring them back into the conversation and enable them to be part of this discussion, really. So we created this web app where you can just upload a photo and so you take a photo and it analyzes this picture and, well, right away tells us a little bit like how does that perform in terms of biodiversity? What are things that are good, what are things that are bad? And then we are able to adjust, it gives us a score of how this performs, and then we are able to adjust this and get a prediction, okay, like if we want this space to be more biodiverse, what could that look like? What kind of a city could we be living inside? So, and this is one step where it's just, okay, we turn a little bit to the right, want to make it a little bit more biodiverse. What does that look like? It then also provides like an idea, a set of instructions of changes it made of how to really make this shift happen. And so if we are like, want to see it even more biodiverse, we can adjust that slider again and we come up with something like this. So the resolution on the screen is very horrible, but you get the idea really. What would the space look like if we really focus on biodiversity here? And I'm gonna run a little experiment here, so one quick show of hands, please, if you would prefer this one over the initial image. Okay. Not as good a turnout as I expected, but yeah. So, but this is really the idea, right? To have to enable people to see the consequences. Like, is this something I want, right? So this is what this is all about, basically. And there is another example we showed from the square right in front of the building, which is a little sad, you could say, and. Also, what I wanted to show here, like in the beginning, there's a short description, but then it really goes also into detail and looks at the characteristics of that place and tells you and reasons why this is bad or why this doesn't perform in terms of biodiversity. So, and if we then process this, and I'm gonna skip over a little bit to the end here, which I cannot do, unfortunately. Yes, so something like that would come out. Again, with the reasoning, what would need to change to go to there. Yes, and also we experimented there a little bit in the end. If we could also turn it in the other direction, like if we have a place that is already pretty biodiverse. Let me quickly see if I can find the spot where the image is visible properly. So, something like that, right? It's a very beautiful space in terms of biodiversity, really well. And the idea is really to show, like, again, what are the factors? Why is it so biodiverse? What is good about it? And then turn the slider, which is down here, by the way. It's a little hidden under the toolbar, unfortunately. But if we turn it then in the other direction, right? Okay, what would that look like if it was less biodiverse? What would we be losing in this situation? Yeah, it maybe return something like that. So, yeah, I think this is the app. I'm gonna hand it back to you now to talk a little more.
Yep, thank you. So I think what this sort of demonstration shows is just how powerful this can be and how quickly we can get a transformation in the way we look at the spaces around us. Just coming back, we have a small number of examples. We'll just breeze through them. So this is where you're sitting right now, showing both how it could be and how it is right now. And I think that one's there for you, Torben. You need to make some changes. Next, we have, again, this is a view of that square right outside. The photo that this is based on was taken this morning. And that was made in the space of about 1 to 2 minutes on this app. And lastly, this is the entrance to DAC, which we include because it's kind of funky in this version, but still very nice. I think I have to skip this part over. Feel free to scan it. Biodiversity is sexy. Thank you.
And biodiversity is online. You can try it out. You can try it out, upload the link. quick, you can also download it. It would be nice if you might want to share that on Square.
I mean, wouldn't it be nice to be living in a green world? But can you explain a little bit what is behind what you're doing? Because I've only seen that you can put a lot of green somewhere, but I mean, like if you're from biology, then ecosystems are multi-species. It's a bit more complex than this.
Yeah, so there are really multiple stages. So first, I mean, when we load the image, it's analyzed, and it's really we try to give it very specific instructions and limit like or narrow the points of interest that it should look into, and really analyze. Okay, where is that? What are the key factors? What is relevant in this position? Where to look for, and to try to make an assessment based on that. And then, like this is when we then adjust the slide. Okay, so we saved that baseline. This is the baseline, and we want to increase it by half much. Like really try to reason and look into the sources we provide. What can be adjustments that are to be made. So it's really broken down in a couple of steps, and then this information, when you're done with that reasoning, what changes to make, feed that into the image generation to really try. In this point, of course, it's all very experimental still, but to try how that would look like if you implement it by this, like if you guide it with some sort of expert knowledge of it.
Yeah, just very quickly to add, we ran out of time to sort of explain the future part of this, but we would be adding, regional variations. So it will give you a different result if you're in Morocco compared to Copenhagen, because we don't get palm trees here. So that's also integrated with the AI and the models.
Oh, I still have one more question. And so this was kind of towards public and kind of citizens. So what happens next when citizens kind of suggest these ideas in these places? What's kind of the process forward to get them implemented in practice?
So I think the goal of this is to change culture, essentially. The purpose is that it gets out there, the public uses it, the public shares it, people react and and it makes people more responsive to their local urban environment, brings it every day, everywhere, as we say. So the next step on this would be to get this in the hands of people outside and to start building, I suppose, a movement around this idea.
And one more thing, like maybe, for example, if a lot of people were to take a picture down there and make an adjustment and post that. So in this app, there's a little share button which doesn't work yet, but it's maybe a tip-off for city planners. A lot of people see a room for improvement here. I think we should be looking into that. Thank you.
Begin? Yes. Hello, everyone. We will try to do a bit of a different approach into our presentation. We would like to walk you and give you the feeling of our actual product here. So if we set the scene, you're an urban planner. It's Monday morning. You go to the office, take a cup of coffee, set yourself into your tasks, slowly get to your first meeting, and then you sit down with your team, you get on the plan for today, a building proposal is in discussion. Could be housing, could be retail, could be anything of that sort. Questions arise in the meeting. What happens if we build a building in this area? What happens to the neighborhood? How does it impact the neighborhood? Will it make it more attractive, less attractive? Flow of people, energy consumption, and so on. The idea is that you want to test, you want to argue, you want to iterate the best result before you do actually anything. The Cities We Deserve, our group, takes gaming logic seriously. with a game-like simulation. I will talk a bit about how we got here. Our passion for gaming got us together and put something from different backgrounds in the industry to one second, to make a product that actually shows that people are not actual outputs to the system; they are inputs. We were actually fortunate to have a visitor from the municipality who saw the digital playground that we're going to display in a little bit, and she immediately showed interest, where she displayed that actual data that municipalities possess today could be put into the digital playground and used already by Monday, for example. Yeah, I will hand it to Iman now.
Yes, thank you. It's a game, so I require both hands in order to play. But if I start playing the simulation, so this is the sun, hello, we also have a moon. You are able to place down housing, for instance, in this area. You can see that the energy needs for your city have gone up. We can place some offices down over here, maybe some commercial. The scaling is not quite right, but you get the picture. You can also place roads that go in between your different areas of your city. And we have population simulation flow as well. So you can see over time throughout the day, how does your population move between different parts of your city? And that affects the GDP, the land value, the tax. So you can see a lot of people going to their offices or back from the offices around 5 o'clock or so. But you can see the energy. We don't have any energy, but we can add a wind farm, for instance. And you can see our GDP has shot up because people aren't using wood in order to heat their homes. They have electricity. So this is how you can interact, but the ultimate goal is it should be in real cities and used for real things. So this is a model of Copenhagen, or the Nordhavn district that we added. So all of these are real structures which are contributing to the simulation of the model. And if we add a nuclear power plant, for instance, right in the middle of Nordhavn, then you can see that it connects to all of the different buildings using Prim's algorithm to connect everything automatically. But you can see that if I place down a park, for instance, over here, that the health of your population has increased. And yes, so you can also switch what season you're in. So winter, it's much lower, and that affects the energy production from solar, for instance. The wind power as well, we have a random algorithm that fluctuates. So the purpose of this is you can fiddle around with your city and see real impacts. How does this impact your tax take? How does this impact the stability of your energy supply? How does this impact the land value of your city? So there's a lot more we can do to expand this. So we also have metro functionality. So this is the new M5 line that I'm creating just here. And citizens can decide to choose different methods of transport, and that will affect the GDP. That will affect the time that people take to travel around your city as well. And I think the grid, yes, thank you for reminding me. So yes, you can see this is just the infrastructure. At the moment, we're doing this all automatically, but in the future, it would be the real infrastructure. And you could see, okay, we added some more renewable. How does this impact our grid? So renewable energy is causing a big problem for grid infrastructure in many economies, and that's something that cities do care about. Yeah.
And if any time left, essentially, I think the conversation was from 1 minute. Nice. about like all of our experiences with like I think we are old enough to experience gaming, indie games and so on. And like all of us except me for CLIs are tired of chat boxes and other interfaces, and we maybe reminisce with what we had before. And this was an idea that how we can, like how fast we can do it with AI this weekend to create something that we really liked before, but for something that we really need today. And then we started like coding with a lot of agents, and then there were like different point of view from transport, product, to architecture, city, BIM management, and in general construction. I'm waiting for you, but yeah. Yeah.
I can take the first one here. So there are a lot of elements that you have considered when you are to evaluate it. There are a lot of parameters that you have to consider with all the analysis that you're doing. So what are there any standards, or what has been the basis for saying this is the energy consumption and it's green, yellow, or red, whatever?
So I can tell you about the endpoints that we are planning, and we kind of created adapters for to get the real data from electricity map, EnergyNet, and so on, and the formulas. And actually, the very interesting part, because we put our passion and everything that we knew. Like he knows a lot more about it, and Iman can explain where we got all of those information from.
So for energy, for instance, we have different energy profiles depending on the type. So housing, for instance, there are peaks in energy use. So like 8 o'clock in the morning, in the evening, during night, there will be no energy use. Offices, commercial will have different ones. So at the moment, there is no basis to it. We've just used our brains, but that's something we can easily adapt and tweak for whichever city that you're looking to play around with.
Okay, yeah.
Okay, so basically a digital twin for a city to do any kinds of simulations you want. So did I understand correctly that you actually built this from scratch this weekend?
Yes.
And you were able to populate some of those buildings from Copenhagen from basically kind of like 3D building data that's available?
Yeah.
How much would it take to populate the whole city and also all the roads and maybe energy information and everything to make it actual digital twin?
I guess, Chris, whether you want to talk about the GIS side. But
I think that would be very interesting. What the reason we made this, we wanted to make this available for a 10-year-old person, and also, like, I don't know if you're a professional, but if you're interested, for example, I think like Chris was working on ungraining all of this information. It depends. It doesn't depend on us because we deliver what we receive, and I know like CityWeft, and there are a lot of APIs that can provide that information for us. And we try to make this as playful as possible. But that is like, it's not our area, but we are ready for it, if it makes sense.
Yes, one last question. Like, what are the rules? So how do the agents actually communicate and negotiate? I mean, like, because...
yes, the population engine. So they don't communicate with each other per se, but you have a pop who lives in a home. They go to an office at a certain point. We have a mix of sort of ages. So some smaller pops, they go to school at a certain time and come back from school at a certain time. So there's not much interaction with the transport layer. We can just see how many people are taking the best path, but in the future we can upgrade it to make it a bit smarter.
Mm-hmm. So it's people-centric, okay. Nice.
Yes, yeah. Thank you.
There's lots of seating down here if you want to come and scooch in.
Hello, everyone. Thank you for coming to listen to us. We are Go Wombat, an IT company providing data-intensive platforms for our clients in the physical world. We are a new member at Blocks Hub, and this is my team with me today. I am Oksana, the head of partnerships at Go Wombat. Stas Dragun is our leading data engineer. Stas Kramer is our leading AI engineer. And when we decided to participate in the hackathon, we turned to our friends and long-term partners, Eindom.com. Asking them, guys, maybe you need some help from us. Do you have an idea? And they provided us, maybe some of you heard during the presentation, Henrik presented his idea of kind of creating a more interactive and interesting way of communicating with databases, with tables, with columns, with cells. He actually said, guys, I feel bored. I need some fun during this work. So we came up with this idea of creating digital twin city for Copenhagen. We are going to show you how one agent is working using 7 data sources on the 3D Copenhagen. Because we were told to to say exactly who this POC is for. Of course, it's first of all for Eindom.com and their clients who are property managers. And we think that urban planners and municipalities will find this future to be a very successful application, very useful.
So on to the demo. As you can see, we can ask an agent to take us to any part of Copenhagen. I asked it to take us in a very specific part that we chose for this demo. I can ask the agent to create a report on a given building that will tap into Einddom's API and compile a whole report about risks, maintenance costs, about observations about the building. So it is very helpful for property managers that can help property managers to maintain the building. Also, we can ask the agent to map out the green areas and trees around the building. So this is helpful from a biodiversity and urban planning standpoint. So this kind of gives a visual idea of where the trees are, where the green areas are, and maybe can help an urban planner to think how to improve the area around the building. So also we used Molia's MCP server to connect to the BR18 data for the building. We can ask the agent any sorts of questions, all sorts of questions about the BR18 regulation in general and in the context of the building that you've selected. So you can, we should get back a bit, but okay. Yeah, how it works, a bit of a technical outlook. So running underneath all this is the Claude agent as SDK powered AI. The front end was built with React and a MapLib 3D library for 3D rendering, and the back end is on Fastify on WebSocket, basically. And for the data sources, I'll hand over to Stas.
Yeah, hello everyone. Regarding data we are using, first we are using data from Eindom.com. It provides more than 1,000 buildings in a Copenhagen area. Also, we are using Molio MCP to retrieve law regulations regarding this building. Then we're using several Danish open providers to retrieve extra information regarding addresses and other information regarding building. And of course, some open source data like OpenStreetMap and so on to render this on the map. So regarding the data, like the main problem of all AI agents are hallucinations, and we did our best to ensure that we provide with reliable data. So every fact that's made by our AI agent is API sourced, and we like make link to it. And also, if any API doesn't work, we say explicitly that we cannot retrieve this information instead of trying to guess it. So that could be relevant because using our data in our application, you can retrieve like energy specification for the building, possible maintenance to make it more CO2 neutral, like heat pump upgrade and so on. In terms of biodiversity, you can retrieve like green areas, trees, parks, and so on to understand like what happens and what could be done then. And also because you can just chat with AI agent in natural language, it is accessible to everyone, not just to experts. And our next steps we see is first of all to scale to all Danish municipalities, because currently we are working only with Copenhagen. Then create a deeper integration with Iron Dome to retrieve even more information regarding the buildings, and also create our own sustainability scores when we have a lot of data from different APIs, and also create an open integration API so every data provider can connect to us using just BBR ID of the building. Thank you.
What do you base your sustainability scoring on?
We currently do not have it. It is the next step. What should be developed?
What would it be, kind of?
Like based on, yeah, we can retrieve more data from Iron Dome based on like energy ratings, maybe how effective the building is. Then we can also retrieve data regarding the energy consumption, for example, and so on.
Also, we have we can source data from Copenhagen Open Data, which we can use to, for example, quantify how many green areas are there around a given building, or how many, what is the solar potential of the building, and then we can, using the numbers from that API, we can kind of create an aggregated metric to score a given building.
Across multiple buildings or one building, or yeah.
Sorry?
So like so your selling point is that you can visualize a lot of different data points or databases, bring it together, and then you can inquire one or multiple buildings and
so currently we can only ask about any specific, like multiple specific buildings. We can't ask about like multiple buildings at the same time, but you can ask about a neighborhood or about some bigger part of the city in general, like how green is it, how much solar potential is in there. So yeah, you can ask, you can answer all sorts of questions regarding the neighborhoods.
Yeah. This was good to see the visualization of the digital twin as such. I want to know that if you want to sell this or want to sell this to Copenhagen community, like municipality, what more you have to do to sell this to them?
So currently we're probably considering creating our own rendering engine, because right now the map is a bit flaky, so we'll have to work on that. Also we plan to tap into more data providers to maybe again support more property managers so that the coverage is greater, because right now we fully support only Iron Dome's portfolio.
Yeah, thank you.
And did you build everything from scratch?
Yes, so we only did some research before the hackathon to see what data is available out there, but the code was all built during the hackathon.
Okay. All right, impressive.
Thanks. Thank you.
Concrete sorted.
Test, test. Oh, I hate using these microphones. Anyway, we are Concrete Clauses, and we are building concrete legal solutions for your concrete projects. I thought that was a funny one-liner. Very quickly behind the team, my name is Andreas. I have 5 years experience with like entrepreneurship, building AI products. I had my own startup before, and also just like general product development. I have my good old friend, also Andreas, who has 3 years of like professional full stack experience, but has been coding for since I knew him essentially. And then we have Victor, who is an aspiring product manager. He's going to start with software development, and he has really been our busy horse because none of us are lawyers and none of us know anything about the construction industry. So this was a huge undertaking. So he just made sure that we were kind of at least semi knowing what we are talking about. So law is complex everywhere, especially for the construction industry. And not everyone has legal know-how or has access to legal help in-house in the different contracts, whatever people are part of a project. And it's also just, there's such a lack of overview. Like even if we just take the AB rules, as we have kind of narrowed down in our little tech demo, there's so complex to navigate, so many clauses, and it kind of becomes unclear the allocation of responsibility. And that can lead to some disputes going over time, going over budget. And that costs billions of Danish kroner every year, just these lawsuits and disputes. So there's a huge problem with everything in law, also other places than the construction. And while I'm not an AI researcher, I do have AI know-how, and I've spent the last year kind of looking into legal tech in general, trying to understand law. Again, I'm not a lawyer. But I do think that we might have a better way of structuring law with AI. So law is inherently structured. It's not just flat text. Reg might have a problem with like traceability, auditability, like how did it actually get to the results. And it doesn't really think like a lawyer, which is a hope that I have for the future of this solution. And because of all of these problems, that is why we made the law into a knowledge graph. We actually did the very boring work of taking the law and breaking it into its like subatomic particles of main rules, exceptions, and exception to exceptions, and all the other things. Map the relations, map the conditions of how they actually relate to each other. So when you actually ask a question, the question kind of traverses this graph and finds the correct path that is relevant to your question or to your course. We don't use any cosine similarity or any best guesses of what clauses are relevant. If we are unsure where the next step is, we will ask a question. So if it's about time delay, how many days, or why was it that the delay was there? So only then, when the graph is like complete, has the specific clauses and the whole mapping of that, it will then feed into an LLM, so it can actually like give it to the user in a more digestible way, ask follow-up questions. We query the graph, and the key principles or the hope for this is that we can find an exact match for your problem, not just the best guesses. And maybe also add some transparency. So if we can actually visualize this graph and what path it took, it can maybe create some trust, maybe some trust across the partnerships in these huge projects. And a little bit about what we built and what happens now. So everything you're going to see, all the code, the visualizations, and the knowledge graph was created this weekend. The only thing that we did before is that I have looked into the legal tech a little bit. A month ago, I started looking into the construction industry. So I saw this hackathon. I was like, we're going to test the idea here. My girlfriend is studied law, so she kind of helped me a little bit in understanding how we're going to actually do this. And what are we looking? We're looking to continue. Hopefully, if this works, create it into a startup. So after this, come talk to me if you know anybody who want to try it, to test it. If you have some specific cases that could be interesting to look into, or if you have any money, of course. So before we go into the actual tech demo, we really narrowed it down because law is a big thing. So we just took the AB rules, mapped the AB rules to our best extent, of course, and see, can we actually extract relevant information just from the knowledge graph? No web search, no reg, no nothing. So bear over with the limitations of it. I'm just going to go over here. So here we have our chat user phase. It's in Danish, I'll translate. We asked the question that the contractor is 6 weeks delayed to actually deliver because of bad weather. It goes through the graph, actually says that, because it was bad weather, he actually has a rightful extension. It will also give some conditions to what the weather is supposed to be, and also give some recommendations. But we can also click on the graph. It's the whole knowledge graph, and it actually lights up the relevant paragraphs. So we can actually see the whole graph or go through the timeline to see what clauses were actually relevant. You can click on the clauses to kind of see what is it actually about. And I think in a minute it will get to like the final, which is because it was due to bad weather, it is a rightful time extension. And that is the final note that we will click on. It'll also say conclusion. And in the next, just to show that it at least kind of works, we're going to ask the same question. It's 6 weeks delayed, but without a reason. And because it doesn't like vague information, it'll actually ask follow-up questions like, what is the reason? Figure out the reason so we can actually say. And we say that it's the contractor's own fault. He was lazy. He didn't do it. Who knows what might happen out there? And then it actually says that he does not have the right to an extension. And because it is 6 weeks, we really blew it up. There's actually a right to terminate the contract. So that's actually the final note that it came for. You don't have to do it, I think. Again, I'm not a lawyer. But that is actually where it ended up. So again, it traverses a different path, ends up with the paragraph about rightful termination for it. So again, it's more like a proof of tech. It proves that we can actually do this. The law is infinitely complex, so that some of the next steps is actually verifying that the graph is correct, but also see how we can develop more.
All right, good job. Really kind of obvious and logical use case that you came up with. Was maybe one of my questions would be kind of the validation that you can be sure that this is actually right. So you mentioned that you were able to do some kind of validation already with this information that you have in this case, but how much would you need to do kind of further work to really make it a robust tool?
So one of the big critics you can give a knowledge graph is that it is hard to scale and hard to maintain. And that doesn't really scare me. Figure out how to scale it. Figure out if it works, and then we're going to scale it. My girlfriend studied law. She works a lot with digitizing law, actually, in some of the governments. So even before AI, she had experience actually, can we break it down and actually make some dumb decision graphs back in the day with the simpler laws? So I am sure with enough time that we can actually sit down with an actual lawyer and say, what are the actual true? Because we did our best here. It seems right, but we also don't know. So it is getting a kind of a legal team to actually help us actually build it. And who knows, in half a year we might figure out that it is impossible to scale or it's infinitely. There's also some vague terms that we also need to adjust for. So we are optimistic with what we have built today. We got a lot of interesting feedback from other people. So it is just taking it further, and if we hit a wall, see we can climb over it.
Yeah. I want to ask you that you started with contracts are very complex. So when you are arriving to the suggestions or whatever in your tool, who actually tells or defines the order of contract? Is it you're relying on AI, or is it human, or how does that one contract it takes priority over the other? Because it can be multiple contracts which are lying, which is also a problem in companies. So how do you see that you can solve this issue?
Good question. I'm going to take it back and think about it. So again, we just took the AP18, and I know that when you make contracts, you can kind of pick and choose what you want to use and what you don't want to use. So I've also been thinking, because building projects are so big and complex, what if we actually take their contracts and again, maybe even manually in the beginning, break it down to make sure that it is correct. So we kind of have this, okay, we have a $500 million construction. Let's spend a couple of million actually mapping the contract in this logic so people can talk to it to see, oh shit, I'm a week late. What happens if I'm another week late? So we're even thinking like, are we doing this maybe as a consultancy thing? So for now, there's a lot of manual setup for the contracts.
Yeah. Okay.
Next one, Brunellacci.
Oh, thank you so much.
Proprio. Hello everyone, I am Eduardo from Brunelleschi, and with me there is Francesco. And today we want to show you our AI tool. It's AI Power Structural Modeling for Engineer Structure. So it's really focused to the, not yet Francesco, okay. It's for FEM software. It's integrated to the FEM software and reduce the work from days to minutes. Go ahead. The problem is the construction is responsible for 38% of global CO2 emissions. And there is a waste enormous in this sector. It's 50%. There is a raw waste material. So, and of course now the software, the engineering working manually and using maybe some scripts to reduce the time when they modeling 3D in analysis structure. It is really focused, and the work is slow, is manually, and waste a lot of time, and honestly is pulling. Our solution, Francesco, go ahead. Thank you. This is our solution. Thanks to our AI, the user can describe in a plain text, in a prompt, his project to AI, and the AI find the optimal path to do the same project, but less time, reducing the waste material. This is the AI, the video, go ahead. Yeah, this is how it works. It's the functionality is really simple. It's not a web app, it's a desktop app. So it's integrated with your file. So it's more easy to keep the context. And this integration, in this case, we use CAP, is a software really used in Italy. We are from Italy. And this is how it works. The user can write here the prompt, and in really fast, it's integrated to the through API in AutoCAD and other software. Make the model 3D in deterministic and deterministic mode, because inside another problem, if you integrate directly a general AI, he make a lot of mistake. We create a Gen AI using alpha and alpha at the moment, more in deterministic than deterministic. Go ahead, okay. Before the hackathon, we come here with our software, was integrated with Italian law, with NTC 2018, with Aero Code. So was compliance with Italian law, but not in Danish law. For this reason, go ahead, what we did yesterday. And we visit Copenhagen, of course, and we integrate our software to Molio remote MCP. Thanks, Casper, and thanks to this integration, our application now is also compliance with BR18 from Danish regulation. So. This is the result. Now our IT infrastructure is more complete, complete, yes. And this is our software that we integrate. This is a website, so you can also download a report. In this way, you can see the report that generate to a building that we use as example, and in particular, thanks to MCP service, you can see also the credit of the law. So in this way, you are sure that the AI not make a mistake. Go ahead. So this is the real benefit of the platform. These right sides, not over sides, because the problem is the engineer takes too much time to do the project, and the part of optimization is don't give a lot of time. So now the engineer do the work, but not in best way. You can do better, and in this way you reduce the time and less material, lower cost, and of course less CO2 and also less impact in the environment. Brunelleschi AI again give you the time to optimize. What we are now? We are here in Hackathon, and we integrated the MC service, but we also open to integrate with the other service, with other MCP, and in the future we want also to integrate with other software, RISA, Drupal, Revit, Civil 3D, and we want to launch in June 2026. Really, it's tomorrow practically. And after we have 5,000 models, we want to work to build our AI engine using open model like WEN, and do a fine tuning to do the work more better, more specific for this case, to resolve more better this case with less iteration. And go ahead. And now we are talking with 5 engineering firms for pilot projects and targeting more 100 workstations in the first waves. And we are open, of course, we are searching the financial angel and other collaboration, of course. And that's all. It's you can scan the QR code if you want to try it for June 26. You are the first that can try our tool.
So, super. Okay. So I assume that all the kind of local data and wind and snow and other loads are kind of given there. But so your focus is on structural.
Yes, it's
structural conformity. Okay.
Exactly. Load and the also relations and all part of regulation from the law in specific in the nation, not only the form, the 3D.
I have, because you also have this roadmap there. Isn't a lot of the problems why you, for instance, cannot use the optimal beam size here and there, that other disciplines are interfering, so that the facade might not work or the foundation has certain problems and so on? Like, do you take this into account as well? So like this interface, or like the multiple dimensions of the problem?
Yeah, because you can do, at the moment we are integrate with a lot of software. In this way, you can take the context with the same chat, and you can do also the translate between, you can do, for example, you can do a model in AutoCAD, and you can translate directly to the SAP, it's a FEM software, to verify in 1 minute if the architecture do well, the structure, if it's consistent and is practically to do that. This is the main, this is, of course, AutoCAD is working for their AI engine, but our scope is to verify if the result is okay to another AI.
So, what does the AI actually do here? I mean, can you be kind of a little bit more specific? So it's basically confirming that it's complying with these different countries' rules and regulations, or?
It's the AI is use generally the MCP service. In this case, we use Molio for Danish regulation. Of course, Francesco is an engineering instructor, and he validated the model. In Italy, we download. We have our file database, and we storage all of data from the state. So this the AI use the MCP service when he need, and he also use the skill. And we are also doing some script in some case when we have some difficulty, if the AI make some mistake. And of course, we need more time also to validate, to test. For this reason, we need some time, 2 months, to validate more better the product.
Okay.
Thank you.
But you're ahead of time.
I'm waiting for the okay. Yeah.
5 minutes. I just
We go? Perfect. Hello, everyone. We are Core DLM. There was like a late minute change in the name, a bit of debate. Let's see if it's better or not, but in any case. We are a team of diverse people, I would say, bringing knowledge from JS, backend software development, API and integrations, environmental engineering. I'm Vasiliki, Jonas, Alessandro, Razi, and Maria. And we all gather together with the same, kind of under the same quest, that actually we have a vast amount of environmental data, but accessibility seems to be like still the issue. And when we talk about accessibility, it doesn't only refer to expert, domain experts and knowledge kind of gatekeepers, but also from the citizen level and everyday quests that have to do and are related to environmental data, up to stakeholders and architecture planners. So how the landscape looks like, of course, like only looking at the AEC and only focusing purely at environmental simulation platforms and official kind of scientific tools. There are most probably 30 and plus more, I would say. We only have seen today like, I don't know, maybe 4 or 5 already custom tools that actually tackle the environmental analysis. And I would say that nearly 100% of those are actually referring or require domain knowledge and expertise to unlock the insights and the actual, like, how can you actually use this data? And at the same time, that shouldn't be the issue, that shouldn't be the case, right? So why should, for example, understanding the livability index or how cool or how like heat intensive a street is should actually live under the hood of a specialist's output or analysis? And this problem actually is situated within these 3 domains as a classification. Like the first thing that we discussed already is the expertise level. So for every setup of analysis, data fetching, we need a level of expertise either to fetch and run this analysis or even to post-process this data and serve them to people and citizens. At the same time, AC knowledge, again on the environmental aspect, seems to be very, very fragmented, meaning that there is no like a single tool that serves all scales and all data types and most probably all environmental concerns under the same, again, umbrella. And of course, these tools are costly and computationally intensive. So not everybody, of course, has access to those. So what our solution does is that you simply ask a question and you get an answer with a dedicated analysis exactly targeted to your question, like level of question. So a level of adaptability to away from dashboards and, you know, like data displays. And a bit like to see it more specifically, this is a typical quest from a citizen potentially. So what would be the last windy route, for example, to run today? And then there is a level of orchestration going on in the backend, which is in 3 layers. The interpreting layer, which will identify the persona, the intention, so a route analysis, a location. If the location is not in the prompt, it will actually redirect and ask for more information. Time, it will pass this information into the orchestrator level, and the orchestrator level is responsible for triggering different APIs, which are mostly open source, and meaning that they're also open-ended, right? Like more and more layers and more APIs can be part of this orchestrating process. And the synthesizer in the end takes the output data and synthesizes them, post-processes them in a way that people can actually consume them back again based on the persona type, right? Meaning that also the UI of the actual interface becomes targeted and interactive. And this is actually the output from the specific prompt, right? This is the wind-safe running route in Skjoldsberg area. And also on the raw data output as well, we also display the actual simulation data in order to be able, for someone who most probably really wants to understand where do this data come from and how this evaluation is taking place, apart from the raw. You know, this route is a good tailwind route or backwind route and so forth. And just a bit about our tech stack. Of course, we're actually using, again, mostly open source platforms. All the data are being fetched from like street network data and buildings from OpenStreetMaps, Overpass API, EPW weather data from OneBuilding.org. So in general, we have built it in an open source format. For the simulation engine and for the scientific part, we're actually using the Infrared Cities API for loading urban scale analytics and simulations, wind, solar radiation, daylight, outdoor thermal comfort. For the AI layer, we rely on the Anthropics API. And for the front end, we mostly used Folium and Mapbox.gl. And I think one of the important things to highlight here, mostly the contribution, let's say, of this project, is like these 3 kind of highlighted sections at the bottom, which is one is that it's an open-ended platform, right? It's not intent to lock data from one specific API, but mostly to host things, so it becomes an umbrella. And that's also the agentic part. And also that it's actually scalable in the sense that you can keep on adding data, either coming from biodiversity or from, I don't know, acoustics. Like one could think of many different layers that could take place and be part of it. And just for the outro, and okay, I will just stay here. Probably my hair. But just to see like a quick rundown of what was built and what we built this weekend and what is like the future, how does it look. So what we came with was basically an access to the Infrared Cities API, because this was the scientific basis, right? Just to begin with and validate our process. Then on top of that, we actually built all the orchestration, all the interpretation layer, and all the post-processing of results and UI. And I think what is still at stake, and I think it's next to be demonstrated, is like the fully automated pipeline, right? Something that would be end-to-end and running completely real-time without any kind of in-between hard-coded parts, which we actually tried and succeeded to do. So let's ask City a question, and I will just very quickly display a video of it. And what the video displays is actually 3 different UI description, like output of results for 3 different personas. So the first one was this is the citizen, like a simple route analysis without fancy graphs, but more like correlation of actual urban data. There is a level of the actual expert, right, which looks into more like simulation comparison and actual data, and also the stakeholder in the very beginning, which was an in-between step, right, of data, but also up to the level that it could be useful to the specific use case, for example, real estate property. Yes, so thank you very much.
I can take the first one. It's a good concept to show the safety and different parameters. And in the use case that you mentioned about the route to run safe or so, how do you ensure the data is dynamic?
Yeah.
Or is it, where does the data come from?
Yes, so that's maybe it was the part of the granularity that was skipped during the presentation. So part of this orchestration is, first of all, to extract simulation data that come from Infrared Cities API, which is a a startup which I'm part of that runs AI-based real-time environmental simulations. And the input to the simulation is automatically fetched from forecasting data, right, from open platforms. That means that at the time that somebody quests or queries a specific safety, for example, route analysis, that would actually correlate it to, okay, I want to run now. That was the interpretation layer that we saw earlier, right? I want to actually run this route now. I'm in Skjelsplass or Nørrebro, whatever. And that means that I have a location, so meaning latitude, longitude in space. Then based on that, I can quest backup data, meaning buildings, location, closest weather data, or forecasting if it's a now kind of execution, if it's in 1 week from now. And based on that, get the output wind speed analysis, specific directions or point in time, and correlate the routes, all possible running or cycling routes for the region based on the wind speed, right? The safety of the wind for the specific region.
So what this would require is that there's always this API or the different APIs that you have, they would always be available. So you would need to have a prompt and then you hope that the simulation is very fast. Now the one that you're working is very
and that's why we actually
real time more or less, and but that would be a requirement for all of the different APIs.
That's true. That's true. And actually, of course, for the quests that are more like requiring really like simulation data and not just open API environmental data that are not simulation based, I mean simulation extracted, then that would be a requirement. But I think that was also part of the challenge, right? That we use an API that we know that runs under a second in terms of simulation output, and that can be indeed seamlessly connected. But in general, for environmental data, I think somebody could also easily rely on Copernicus, for example, database, right? Things that have to do with biodiversity that somebody does not really need to simulate it on spot. Even a shadow analysis, it's fast enough, right? Again, yeah, it depends on who is the persona. Of course, if somebody who is expert on the field and really requires maybe multiple simulations, then Infrared City could do that, not to promote the word. But also, yes, I'm pretty much like already like we saw like fantastic stuff. So we were just discussing that this actually becomes like an orchestrator even for many of these projects in that sense, right? That we could hook up many APIs from what it was produced and yeah, basically connected.
Next up is Claudius.
Oh. Sorry, we are missing the extension to the USB-C. My colleague just ran for it, so yeah, all right. Okay, but he already ran for it anyway, so but thank you. Yeah. No to wyjmij komórę. Dobra. To testuj po mojej prawej, nie? Tutaj. Ja stanę bliżej. Tak. Tak. Sapek klika w komputer. Yeah. 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 Okay, there he is. Yeah. All right. Okay, so we're ready to go. So hello, good afternoon, everyone. This is the name of our team, Claudius. Okay, this is the name of our team, Claudius. And let me quickly introduce you to our team. Starting from the left, we have Janek, Mikołaj, Maciek, and myself, Adam. We are all colleagues from Poland, from our bachelors. And now let me introduce you to our fifth colleague, who is the actual Claudius, which is a Polish name, piece of trivia. Klaudiusz is a citizen of a town called Gliwice, located in southern Poland, and he's a very good citizen. He likes to contribute to his community. He likes to see what's being built around his neighborhood. He likes to have an influence of what's gonna pop up around the corner, whether it's gonna be an outdoor gym, a playground, or a street renovated. However, currently, the current solution is not the best. Yeah.
So the current challenge that Klaudiusz is facing is a very unpleasant interface of the participatory budget platform. So an unintuitive interface, as you can see, all the files are all over the place, and also a lack of transparency. So within that files, it's hard to sort and hard to filter all the relevant data. And also we believe that in the current world, most of the interface should include a lot of visuals for the citizens that could participate in the budgeting process. So in response to that, we wanted to create as a team a much more human-centered platform. A platform where Klaudiusz's voice can be much better heard. So the platform could, first of all, have an engaging interactive visuals so that it could include a 3D interactive interface and information transparency so that all the relative data could be seen for Klaudiusz, and a clear stakeholder communication so that Klaudiusz can easily communicate with the urban planners, designers, architects back and forth.
So right now, this is the video which gonna visualize our app. Oh, it's turning on. I hope so. Yes. Okay, it's supposed to be better quality, but this is our app which visualize. We took all the publicly available data around Copenhagen to visualize, first of all, the city, and second of all the investments that are actually happening in Copenhagen. So the first one is the completed investments, and you can look up here the 3D model of the stuff that will be gonna be built with the budget, with all the informations. After that, you can select different types of the projects. So for example, the yellow one are the projects which are currently voted. So you as a citizen can choose different budgets that you have influence on. And for example, we are picking this project. We are looking if we like the 3D model, if we like the idea, and we can give our opinion about it. We can choose from a various of different projects, and we can select also different districts around the city. It's all based on our place where we are living. And the most important part, which is as a citizens, we have the ability to upload our idea for the projects. So here we show that we, as a team, uploaded a duck because we think it's a good idea to have a big statue of a duck in the middle of the Copenhagen. As you can see, right now we select the place, add our object, and we can rotate it, show it, and give all the explanations necessary for other people. Also, we implemented options for architects with the file which is called IFC files, exactly. So it's also available for a little bit more complex projects. And right now I'm giving mic to Janek.
All right, so we wanted also to see if our app is viable and test some of our ideas. So in order to do that, we used Microfiche framework. We didn't have enough time, to ask people around how would they feel about the idea. But we spun up 71 agents and we run them in their time, like 40 hours, and we would see how they would interact with each other. So all of them had different personalities. They were also Copenhagen-based, and we fed them the data of the 10 projects we found on the government website. And we wanted to see how would they interact with the projects and how would they interact with each other. So in conclusion, we found out that the amount of data and their comments and everything was a lot, and it was very controversial sometimes. So they would have really long discussions, and we didn't actually include it in the first place in the platform, a way to interact with each other with comments. So we decided then what in future we will need to add
like a good way that platform could foster some communication between the citizens.
Exactly. So now let me take you to our future plans. So first of all, what Janek has discovered during the small market validation part, the community comments. So the community needs to interact with each other, the citizens with the citizens, and also with other stakeholders. So there need to be a section where people can leave their opinions on certain ideas. Secondly, our idea is to make the app visible to everyone who just have the link. However, in order to participate, you would have to register so that we have high quality data. The identity would be registered through, for example, solutions such as Meet ID, which in Denmark is very common, in order to have actual citizen participating, and also for the votes to be counted towards the projects, since you can only vote once, right, for the ideas in your neighborhood. It should be easily integrated to government websites, so it's not a technical difficulty. And also we aim to develop an app for citizens, so it would be way easier to, when you just come up with an idea when you walk around the city, to just drop an idea for the project through the app. And also, since the main goal of this idea of this project is to contribute to society, it's open source on GitHub. Here you have the QR code. Feel free to scan it and use it as you please. Thank you very much.
Just to understand, your outset was this municipality webpage which allows for citizen interaction? Okay.
Yeah, to see the civic development projects, like for example outdoor gyms and playgrounds where people can vote for those projects which they prefer to have them built around their corner, if they prefer to have the... Yeah, do I understand the question correctly?
Yeah. No, exactly. Yeah. Super nice. This community parts are really hard to actually make, no? So because who's going there? Do you know something about this, like how it is used, or who would use it, or how inclusive is it? Or like that's not just the tech or internet-based people can go there, but everybody, or?
So during our research time, we also found out that only in Poland, at least since we're from Poland, there are 3% of people actually participate in votings for the budgets. So we thought like it's really not a lot, right? So we want to engage more people, and we decided the app is probably the easiest way, since some of the votings are locally, like you have to go to the local government area, or you can do it via internet, which we, like you saw, the website was like bleeding, right? So we thought that the better way would be to interact through a platform that's 3D engaging, and it's much more easier to understand what's going on.
And that's why was the idea of gamification of the app. You look at the lots of colors and lots of pop-ups, everything is moving, so it's gonna be interactive for the people to really do something, and they can go around the walk and, okay, I like this place, I would like to have a gym here, so I propose my idea for a community.
And also I can add it is a great way to get feedback from the community, so that the interaction between the planner, the urban designer, and the community can be back and forth. So it's more or less like a 3D form, 3D spreadsheet, how they can communicate.
And what is the most popular social media platform in Poland? Like
Depends on what. Depends on the demographic, but
would this
Facebook and
integrate
Instagram.
into Facebook then?
Sorry?
Would this integrate into Facebook then? Or?
We have more idea about integrating to the platforms of the cities through, for example, API, that if the city uploads already their design, our app is integrated, so it's already get uploaded, so we can see it visualize it somehow. I don't really see how it will fit with the Facebook, which is more about discussion groups, and this is about giving real-time projects. So for the people that really want to have an idea or are really integrated, it's not gonna be super wide for everybody. We just want to give them tool which it will be easier for them to access. Lots of people are not interested in participating in the community, so we just want to give them tools so they can try to be more included in the community. Skanują ten kod, dobrze.
They're too afraid of our app.
Okay. How can I change if it's?
I think it's with the cord.
I think we're connected. Is this your screen? Yeah.
No, this is not my screen.
No.
No.
That's what I was thinking about as well, but.
No. 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 Afraid of our app, so it's trying to delay it, but we're still gonna make it work.
I will run from mine.
Yeah, run for yours. Yay! Woo! We won the system. Yeah, even though we live in the AI century, we still struggle with the chords. But yes, let's get started. Meet Sofia, an urban anthropologist. She's dealing with piles of work trying to analyze the citizens of a city, to build the city the best way possible to serve its citizens. She's dealing with large amounts of data, gigabytes of raw data that she's trying to put into GIS. Compare the layers. It takes her weeks. Her work is very important because it ensures that the city is well enough for the citizens. It's livable and it's sustainable, but it takes too much time. It takes so much time that we came up with the idea of our app, and we can solve the issues that Sophia is solving for weeks. We can solve it just in a matter of a few minutes.
And so when we want to help Sophia, we decided that we're gonna need to scrape a lot of data. But when we came to this and we start scraping data, we figured out that there are mainly two types of data. Some data that we called hard, some quantitative, some numbers, but also soft data, qualitative. And combining these two together is not an easy task. And yet again, Sophia would have problem because she would have two different types of data that don't communicate together. But there, we had to figure out some workflow that will make it again easier for her and make it just within a reach of a hand. And so what is our workflow? So as I said, we have some hard data, which we got from open sources, many data banks, and Denmark is one of the best ones when it comes to offer this public data. And then we went for soft data. So we tried to scrape, for example, some information from Google Maps when it comes regarding the reviews, and then we could position them on the map and try to quantify them. Or we also use, for example, social media such as Instagram, where we could get the recent posts and we would again geolocate them and we would know which places are visited and popular. So next thing was that we then ran our analysis, so we could all of the data quantify in some way, and we could get final score for 5 categories. We look into mobility, accessibility, greenery, community, and safety. And when we have these data, it would be nice to just combine them and have a final score. But one of the most important things that we believe we should focus on is that we need to see the city through different lenses, that different groups of people have different needs. For example, if you look at some senior, for them it would be much more crucial to have high score in mobility compared to young adults that have much easier time to, for example, commute on a bike or just get to further distances, and they maybe would prefer having a high rating in some other categories. And once we have those lenses put on, we can then get some final report that could provide Sophia with all of the context that she needs to design, building, or develop some urban area.
And now let's see together how it actually works. So let's hope that it works. Yes. So we go into the app and we have 2 displays. The first one is the atlas. We can see that there are many different categories. The first one is the population. The next one is families. We can see if there are families with children or without, what is their income. We can choose different colors for the easier display and understanding. The gradient, anything you want. Then there are also different sensitive areas regarding the traffic or some incidents, anything that you want to put in. Many amenities around the cities, cafes, restaurants, public amenities, anything again. The speciality of this map is that you can put any data set that you want and then get it displayed. And then we come to the soft data. So here it's extracted from the Google Map reviews. It's parks, cafes, and restaurants, and we can see the livability of the area regarding the reviews. Then we go to the lens. And here we can see different points on the map from the lenses. Like right now we're looking from the early, which is 75 years plus, and we can see that the score is displayed over there. And you can see that it's changing regarding when you change the lens and also when you change the location. And what is interesting, when you're in the city center, it was the higher score. And so when you go on the outskirts, it gets lower because there are less amenities, but also usually the traffic is worse sometimes. And just generally the Atlas scores score less. And then we have a very important feature, the AI summary. And that's what's very convenient for our anthropologists, because she can just come there and see what all this data means. And it can save her so much time. So it's a very, very useful tool, and many scientists around the world would be so happy to have it. So if our benefits are not obvious yet, we can restate them. And basically, our app shows very quickly and easy to quantify soft data. And we rely on many open standards, such as the GeoSOM and OGC and many others. You can ask us more questions about it. So right now we're running on the Denmark demo, but this app has all the frameworks to basically analyze any city in the world like that. You can ask us more questions about that as well, because we are striving to be better and build in even more features. And now meet our team, very big and very diverse.
Yeah, so as you can see, we are in total 11 people. We are actually in total from 9 different countries. And we also have a representation of various ages and various backgrounds of what we do, such as civil engineers, computational designers, architects. Thank you.
All right, so what did you need such a big team? I want to know, kind of understand more about your work dynamics over the weekend. How did you work together, and what was kind of how much did you kind of get done in the last 48 hours?
Thank you so much. As you can see, we have a huge software, and it was all built from scratch. And surprisingly or not surprisingly, the dynamics worked really well, because as we can say, connecting AI and people is a very hard intersection. And so we all worked on, we had a team that was specifically assigned to build like most of the code and the app, then some people that was gathering the data from all around the world, some people that were working more in the visuals, some that worked on the strategy. I mean, I could talk about it for a long time.
And I think we also wanted to, exploit a bit the different backgrounds that we have to explore ideas. So we took this as a platform to actually come up with ideas to use technology, because I mean, nowadays these technologies is accessible to anyone. So we wanted to actually, take advantage of the opportunity to prototype very fast, like different ideas, and focus on actually what would be more meaningful for our case study and for, like the problem we are trying to solve. So I think that was the overall spirit that we put behind what you just saw on the screen. Okay.
Actually, I know that you have been dependent on a lot of data, and I know you probably would have hit that you were not allowed to take any of the data or so. So what was your biggest challenge? Because it can be closed.
Yes, I think let's say on one side, I think we can exploit all the open data that is available online. I think what this framework could allow us and like the specialists that we would like to be working with is to have an open framework to also input what we call like soft data that could be potentially also like surveys or, like field research results somehow that could be fed into the system. So I think what you show here is just a demo. So we scraped some data from Google, as they said, or from...
Related that.
Yeah.
For now, or did you already have an API or something for it?
I think...
Okay.
We used a scraper for Google Maps reviews. It was called Epify. And then we also use something called Zshimmer for the social media scraping.
Okay.
Zshimmer, it only allows you to scrape LinkedIn and Instagram, but not Facebook, which was a big miss. But that would be something that could be done in the future, as that's where most communities are evolving.
Yeah.
And what did you do with this data then? Did you use a LLM to extract like quantifiable stuff? Okay.
Next up is sub-layer. Sub-layer. Are you at home? Yes. Would you like a headset instead of a hand mic? No, or is that okay? After sub-layer, we have a break. So how does this work? 10 minutes. 10 minutes break after sub-layer. Second, I have my controller. Okay. Right? Yeah.
Quite a big difference in team sizes, right? Now I understand why I couldn't really convince anyone to join my team, but fair enough. Here we go. All right, so this weekend I was working on sublayer, and sublayer is the context intelligence layer between subcontractors and construction platforms. Let me just close this. Here we go. And two trends kind of informed or gave me this idea, and the first one is that AI is kind of challenging a lot of jobs, right? But when it comes to subcontractors, that's not really a problem. They are the least impacted by AI at this stage. So subcontractors would be the carpenters, the bricklayers, electricians, and so on. And then the second trend is about the fact that AEC platforms are increasingly adopting AI strategies that will allow agents to get access to those platforms. And this is related to the distribution layer. That is kind of materializing slowly. And the bet behind this idea that I'm working on is that these two trends will continue, right? The subcontractors' budget will increase, and they will have budget allowance for intelligence layers like this. So what is the actual problem that that sublayer is solving, right? A little bit of context. Subcontractors already do a lot of capture on site, right? They take a lot of pictures, they do voice memos, they have long chat histories on WhatsApp and Telegram. They do phone calls, and they do also observations and all kind of issues. And the main problem is that information is not really structured, or it's informal, right? And the CDE platforms are looking for a specific format. And the reason why they have this information in such a way is because they don't use the platforms, right? They have platform fatigue. And that's because every few months they need to go to another project, and that project normally has a different platform. And then the second problem is that they don't have time for training. It normally takes them 2 weeks to do the job and 2 weeks to learn the platform, so they just do the job. And then finally, the channels they are asked to join are the wrong channels. It interrupts their current workflows. And the impact of that is that the general contractor teams need to pick up that admin work and kind of do the record keeping on their behalf. So to solve this, we're creating a context orchestration layer that is translating this informal communication into structured CDE records. So here at the bottom, you basically have the way that the subcontractors work, and they do a lot of their communication through WhatsApp. And then we take those raw messages and we push them to sublayer. And sublayer is basically the context enriching layer. So it knows the previous conversation, it knows the project details, and then it also knows all the APIs from the platforms. So it can translate those informal messages into CDE native elements. All right. So yeah, you have basically the contractors at the bottom. In the middle, you have the platform and tool agnostic layer, right? So if they change from to a different tool, they can still have the intelligence layer of them. And then at the top, you have the general contractors, the consultants, and the owners. All right, so I prepared a little demo here. Let's see if this works. All right, so let me make this big screen. What you see here is basically a person that is laying tiles on a concrete floor, and he encountered the issue. So he's writing a message to his site manager saying that, hey, the screed is cracked. I'm going to skip a little bit ahead here. And I cannot do my tile work, right? And it's in this room. Right, so then he sends this message. Oh, he also attaches a picture. And he sends this message further. And then it ends up on sublayer. As you can see here, it's enriched. It has a location now. It has a type. And then that's it from his perspective, right? But now he can receive a message back on WhatsApp with that ticket that in this case is coming from Katenda, and he can see like a URL from that ticket directly. All right, so now let me see how I go back to the presentation. All right, so what's the value behind all of this, right? For general contractors, they get a structured way of get structured data on their platforms, right? So no more chasing subs for submissions and issues. For subcontractors, they keep working in their space. They don't need to kind of change their ways of working, but at the same time, they are enhanced with this intelligence layer. And then for construction platforms, they get rich data in their native elements. In their CDE elements, yeah. So that's kind of the value for every stakeholder here has something to win. And the current stack. So I'm not technical. I have a business background. I'm a product manager. So I used NN8 for the backend and Supabase, and then for front end I use Lovable. And I'm not sure what's the stack behind Lovable, but I guess it's Tailwind or something. And then lots of Cloud Code. Yeah. So what I have today is the WhatsApp integration, the records audit for both raw data and enhanced AI messages, the image analysis, and then the Katenda MCP, which is not public yet. And then that's what's coming next. And yeah, this is the stack, and that's what's coming next. So thank you. That's it.
All right, good job. So did you build everything from scratch?
Yes.
Okay. There's actually a startup in Finland doing exactly this
nice.
already. That of course shows that there might be a market for it, and whenever there's competition, it's a good sign.
Yeah.
But I can connect you with
I
them.
would love to.
It'd be interesting.
Thanks.
Yeah. So yeah, I mean, what's your kind of plan to do next?
So yeah, a team. Hopefully social work can spare some people here. Then trials on site would be nice. I have a general idea of this flow, but it would be good to have it in the hands of the users. I know there's like connectivity issues on site, but WhatsApp, I think, kind of does the local messages and then it kind of syncs them whenever you have connection, so it might be just good enough. And then once those trials, and if those trials are successful, some kind of commercial commitment, and then continue building the functionality, right?
Okay.
Yeah, it's a very viable problem that you're trying to solve, I must admit. I had this question about when you talked about WhatsApp. It's more like a personal app, right?
Yes.
And also with the cloud coming in, it's also somewhere lying up in the cloud.
Yeah.
So what are the data privacy considerations that you might have to consider if you haven't done right now?
Yeah.
Because people might not be that favored to let you access to WhatsApp.
Yeah. So the way it works right now, you have to talk directly to the layer. So it doesn't have access to your personal messages. So all the messages that you send are kind of only with the layer, right? So if you want, you can forward a message, but it's not actually part of your group chat, right? So you have to push information specifically to that chat.
So you have to select the WhatsApp messages and then do an action to send it to the layer, or what?
Either you talk directly to the layer, or you forward a message from the other groups to the layer.
Okay.
And do you have some bidirectionality in in mind? Now you go upwards, but
yes, definitely. So on the way down is all about getting updates from the tickets. So if it was reassigned or it was the status change, things like that. And also the URL that you saw, it came from the platform. So the URL at the end that came from the platform. So you get access to the actual ticket if you really want to go back.
But is it a problem often that there are so many tickets that you cannot really follow up, and then you sit there with your tiles and your floor and you go home, kind of?
There's a lot of tickets, but I think for individuals, there's not that many at a time. So I think it's manageable, but that's why the trials are there. So we can actually try it on site to see if that's the right approach.
Come back at 3:24. That's when we keep going.
We would like to present to you today our platform Repurposed, which is a platform for reclaimed construction materials. As you can see in the middle image, the practice in the construction industry about 2,000 years ago was that when a building was demolished or taken apart, the construction materials would be reused in the construction of something else, something new. Along the way, the construction practice nowadays is to demolish the building entirely and to dump everything in the landfill. And this is a topic that we decided to tackle during this hackathon, and to create an infrastructure a digital infrastructure to, sorry, next slide. Exactly. This topic is what we decided to tackle during this hackathon. As you can see, the market for reused materials is pretty big. Evidence to this is the multitude of shopping websites that you can find online. However, the construction industry has a difficult time at the moment to introduce the necessary change to reuse the building materials. And some of the problems with that is that to each of these websites, the data entry is manual and separate. There is no standardized overarching platform for smoother logistical chain. There's limited data entry available, and yes, the market is very fragmented. So yes, we, as part of this hackathon challenge, and the goal of Repurposed is this overarching platform that can bridge the supply and demand in the market.
So as Edita mentioned, we want to try and bridge supply and demand from the side of the supply, because we think there is demand, there is supply. The only problem is that on the supply side, they are not able to provide enough data for the demand side. And it's quite tricky to do this because they're all quite small, have limited resources. So our idea is we introduce kind of hard schema in the middle and provide some interfaces there, material passports, IFC and PDFs, and some 3D viewers. And we try and see to which extent we can help the suppliers to inform the schema by with AI. And then, so yeah, that's the same. So yeah, what standard in the whole thing, of course, like we have a standard marketplace. Then we very quickly get to the input view, where you have the traditional form on the right, and on the left you already can have the visualization during entry of how the material passport will end up looking, and your 3D visualizations. Yeah, this is an example of, this is just where we tried with Gwen to kind of see whether you can, from an image already, extract key information to populate the schema with, and which worked quite well. And you have a traditional table view for stock management.
Press the play. Oh, strange. Yeah, so based upon the schema that is generated by Repurpose, what we rather do over here is the visualization that you see. It's not any CAD model which has been created by anyone. So this is generated on fly. The PDF drawings, the 3D model, and all the things that you see over here is generated using the schema. So you don't necessarily need a CAD designer, any authoring tool to create these things. So you have a PDF generated. So what we have rather tried to do is touch an industry problem related to auto drawings. So that has been done as well. And not just PDF drawings, but we have IFC that can be exported based upon the schema. So no authoring tool, no CAD designer, and you have an IFC that you can export into any tool that you want. And along with that, we have a material data sheet, a nice UI that you can forward it to your potential clients and customers. Yeah.
Yeah, and from the designer point of view, when we want to design a new building, basically, you have access to limitless number of new materials. But when you want to use a reuse material, you really know, as a designer, you need to know what is accessible in the market. And As a proof of concept, we developed a script just in a design software like Rhino that can directly connect to the market space and show you what material is available based on your query. For example, here we wanted to see how we can use these bricks in our design, and then it automatically bricks for example, here 3 kinds of bricks. Just put it in your wall, and you can explore the design possibilities. This is also just a fun exploration of the material availability. You can just sweep left or right if you like it or not.
And then just to end with, like our tech stack, so convex, simple, backend as a service, front end as a static next page, and then on the supply side, we're using Quen, locally hosted, like 6 billion meter parameter. And then on the far end for generating geometry, you're using only open source applications, mostly Open Geometry from Visio. And this thing makes this thing that we can get to a price point that we can really offer a meaningful value to the current ecosystem in reuse. And then this is part of a bigger thing. We tackled the marketplace, the middle one, but future scope would kind of slightly touched on long-term storage of material passports, but we would really also like in the future try and tackle to align the deconstruction and new construction for the planning and help with tools for assessing and compliance and certification of reuse materials. I explicitly didn't touch this, but this is the scope of repurposed in the end. And then finally, this is not a project that is in a vacuum. Like the Open Geometry is from you. And last year, I and the whole team did AEC Flu, which becomes Step to Reuse, which was for repurposing of concrete, which was a direct inspiration also in the end for the ideas for repurpose. So we're Edita, Emir, Visio, Jonas, 2 architects and 2 ex-architects that turned software engineering. And this was repurpose.ch with DK being registered, but apparently it takes some time to get that.
All right, super important topic, and this is actually exactly something that we're looking at in Finland as well at the moment. One of the biggest pension funds is really focusing on circular construction, and they noticed that it's a super fragmented area with different types of marketplaces and platforms, and we need one to integrate everything easily. So would like to discuss further on maybe with you guys also. Can you go back a little bit about how do you actually tap into those different sources of data, and how do you get that offering to your platform in that sense?
In the end, I would argue that it's always the hard question, because in the end, the key thing is, what is the schema about? Because until you get to that schema, it is kind of hard, and it is a bit. This will be a back and forth. It will take some time to more iron out. And from the beginning, like it is a general problem in the AEC industry. You always, on the one hand, you have geometry, and on the other hand, you have attribute tables that exist kind of next to one another. So you will never solve this problem, but I think that the scope of reuse is kind of defined enough that it will be possible to relatively quickly get to something that is like 99% working, I think.
Okay.
You said that you made some AI component here which captures like window sizes, or do you take a what was that like?
No, it's a Quen VLM, but maybe Emir, you can.
It's just a use of a Quen model that captures mainly the visual things that we can see from the image. For example, it can guess what type of wood it is, what's if it's weathered, how much it's damaged, or like very high level information, not exact dimension, and so those information should be come from the supplier, and then there will be some complementary information coming from the AI, which helps us to populate more our database, basically, with more information, so later we can search for it better.
Like I know that there are possibilities to extend this. It's just like the more expensive your model is, the worse your value proposition comes. And this was a very cheap model that actually already gave quite good results for qualitative attribution. So.
There we go. Yeah, hello, welcome everybody to our presentation. First off, our group has decided to go with a case presented by Henning Larsen, which mentions to gather and visualize quantitative data relating to the social context of a particular location. It also mentions using data sources to create a visual representation that reveals the social landscape of the area. Now, our initial thoughts when we encountered this case is, who are we designing for? And we have identified a few target groups, being urban planners, municipalities, and NGOs. So what challenges do these people face? One challenge is that of data fragmentation. We have a lot of data out there spread across different websites and all in different formats. It's a very time-consuming process to collect, compare, and analyze these data. Secondly, we have the time-consuming process of collecting and interpreting data, and to use specifically for the reflecting on the social context of an area. And without understanding the social context of an area, the urban planner has limited ability to make design decisions based on real human experiences. Thirdly, it's a time-consuming process to create presentations of data-driven insights, for example, for external stakeholders. Yes, so our solution to this is to create one unified platform that connects, collects, compares, and analyzes data to use for urban planners. And this will then result in data-driven insights and supporting urban planners in making informed decisions when it comes to designing for urban areas. So let's jump into our user case. Copenhagen municipality owns a plot of land, and they do not know what to do with this plot of land. So they hand over the case to their urban planner, and they tell them that they would like the plot to be designed to be coherent and to create value for the existing area. The urban planner is interested in knowing about the demography of the area, and therefore they click into citylands.dk and they type up the address. And that could look something like this.
The quality is not that great. Okay, so this is our solution that we kind of vibe code yesterday in the middle of a loud party. So you go to citylands.dk and you see the map of the Copenhagen, and let's say we choose like a plot of land in the south of Copenhagen, in an like it's an empty land, and we want to know what to do with it. So once you pinpoint the location, you can you can see the demographies and like the median income of this district, and also like you can see some social metrics that we got from from Google Maps. And then you ask the AI agent, like, what can be done in this land? And basically, here it would respond like, okay, this is there is a service void in this region, and it would recommend me, for example, to build more cafes and more restaurants, and also residential areas. And if I ask it, for example, like, what's the segmentation of the population in this region, it would tell me, for example, that it's like mostly single people living here, and also that it's international workforce. So I can interact with the chat, and basically it queries the data, and it also correlates it with the social data as well, and then present it in this interface. And yeah, like we can see some layers here, for example, for which data is used for the AI context. And also for the comparisons, it's kind of the same data set that you guys use. So yeah, what's the impact of our solution? It's basically a discovery tool that's targeted towards like urban designers and municipalities to just explore options without committing to any tool that needs a steep learning curve or anything complex. So anyone basically can use this tool to even get decisions like, where do I open my restaurant? Or is it a good location to open my restaurant, for example? The next steps, of course, like we worked a lot on the data side. So we were hoping actually to include some mobility flow data and like other types of data, and to personalize the agentic assistant more. The project is open source, so feel free to clone the code and play with it. And also feel free to try it right now and like just ask about your where do you live, for example, and like what's the situation of the district and what's around you, basically. So, and this is our beautiful team. So, and that's it. Thank you.
I think what is nice is that you have already like some simple social data in, like income, etc. And you have really nice use cases, so I can understand what it is used for. But would you also link it then further to scenario building or other cases? Because you very much like visualization of what is there, but wouldn't it be also interesting to move forward?
It's mostly like a visualization tool. So our goal was basically to take this publicly available data and also like use some social data if possible and visualize it for everyone so that everyone can use it more or less. It wouldn't be a tool to design anything, but more to explore just what are the possibilities. It can be used also for a specific target group or something like, but yeah, that needs more work, I would say.
Yeah, but also the application is very flexible because we have two types of data. One that is the static data, that is the census data, but we also have the data that is from Google Maps. So basically we get reviews, and these reviews from people, they are real-time reviews that change. They're going to change, and they're changing right now because people make reviews of places. So basically the AI can take the reviews from the places around the address where we want to build, and it's about the urban planner to imagine a scenario based on the review of the people.
Yeah, it's really nice to add. You wanted to add something?
No.
No, okay, yeah. So it's good to see that you using the AI and vibe coding, you could come up with the solution and see and test it as well. I'm also curious to know, how do you plan to validate whatever you get from the solution that you're building or whatever AI suggests you?
So here the AI, we are trying to limit it to just like say its opinion about the data that's available. So it doesn't provide any new decisions or something. So basically just like as a chat actually interface,
Okay.
but with map as an interface as well.
Okay, yeah.
And yes, evaluating this model is very hard to do, like at least in this time period. But yes, how Caleb said, it's more like an exploration, sparkling the curiosity of the urban planner to try to create different things faster.
Yeah, because that would be very important if you use AI for creating something.
Did you build everything this weekend, or did you have something before?
Last night.
All right, good job.
Next up, Phil, Tim.
I need to see the screen. Yes. Hello, everyone. My name is Marius, and my teammates are Ivan, Elena, Christian, Kim, and Dima. And we are Build Better BIM. The reason we formed this team, because on Friday afternoon we got asked the question, what if we could reinvent BIM from the scratch today? What would it do, and how would it look like? And it kept us thinking, and we thought, okay, let's go back to the basics and see what was the idea of BIM in the beginning. And of course, we came back to Charles Eastman, the godfather of BIM, who asked the question back in 1970s, what if a building was a database before it was a building? So he was already thinking about the building to being a database, and he wrote a paper which had 4 pillars, and one of them was one model. So it was supposed to be one model, not many documents, a single digital representation of a building. Smart objects, so we have not only geometry, but we have a meaning, materials, cost, and whatnot inside the model and the database. It was supposed to propagate changes, so if you change a column or a structural engineer change column, the architectural column would change as well, for example, so it was an interoperability and communication. And the model was supposed to live forever, or at least throughout the life cycle of a building, to not only design construction, but also the operation. So then the idea was good, so we didn't want to change it, and I think we still strive for that. But then we thought, so where did it fail? If it failed, and it did. So we thought that the I, or the information in BIM, kind of died, and that was because when it got popular, software vendors were delivering and selling the 3D modeling tools more than information management tools and databases, and that was more sexy, and that's what people bought, and that's what sold, which led to different vendors creating different tools for for different purposes, and they were all built on proprietary data formats, file formats, so they wouldn't talk to each other, and that's what led to vendor locked-in. And then the model usually dies at the handover, if not at the end of the design. So how is the industry trying to change it or fix it right now? So we have different standards and communities that are trying to fix it. We have ISO standards that describes the information exchange and how the information should be exchanged during the construction or the design process. It's still a file format, right? And file exchange format. It can't fix the tools that's underneath that are incompatible. We have also different open source formats, OpenBIM. We have IFC, which is a right destination. It is a right idea. It doesn't really solve a problem on which is it's still a format, first of all, and the software vendors doesn't really do their job to integrate or to do the integration with the IFC. And then the digital twin is a new buzzword, which should be just BIM in the beginning, right? And it doesn't really make sense since we are building into the broken foundation and the incompatible data. So that's what we thought. And then our solution is we created a open source AI-enabled community-driven BIM platform. And now my colleague will show it.
Thank you. Yes. So what is the problem with using AI for construction? It doesn't know your rules, and if you give it a big task, it will likely hallucinate and give you something useless. So we've created two solutions, or it's split into two, this solution. We have a vibe coder that lets users generate and create their own BIM features and rules, and also share them with the community. And the second is a BIM platform that is accessible to an AI, where it can use these tools. So this is not the next Revit, this is the platform that will create the next Revit. Tagline. All right, so in the demo here, it's quite quick, but let's imagine we have a new user in the platform. The new user will create a couple of walls and finds out there's a missing feature. It's called corner join tool. I'm not a Revit user. So we'll see this user using a prompt to generate this feature in 5 minutes, which was the real time to do it. And he'll like it so much that he also wants to share it in a marketplace. And then I think this is the point. Yeah, so this is a new user. It was very quick. But there's a new user going into the system and boom, there it is. So let's see. Yeah, so the new user is also generating 2 walls. Selecting them and using the new tool. Awesome. All right. So a demonstration of what can be done with this approach. So we have an AI, doesn't know the rules. Now we have a platform where you're getting continuously new rules, up-to-date rules. And with it, we can do something like this, creating an entire neighborhood fully modeled with photorealistic textures, which should pop in here right any second. Is it coming? Come on. Is it there? Yeah. Amazing. Yes. So I hope the idea is clear. If we go to the last slide. Yeah, it's your BIM, it's your rules, your tools. If you think it sucks, create a new feature. It's up to you. Thank you very much. Passed a bit.
All right. Couple of questions. First, how far are we from having a new Revit running on your platform?
Go ahead.
Depends how many users uses it.
Okay.
It could be very quick. And again, the Revit has a lot of features that we use probably, or individuals use 20% of it or maybe less. So here you just can create, you don't need to recreate the Revit. You create what you need.
Okay.
We don't want to recreate Revit.
Also, as IFC is an industry standard,
Yeah.
and also a lot of governments have adopted it. As, for example, in Finland, IFC is now kind of official format for the building permitting process. So does this comply with IFC as well?
Yes, so you can add any schema behind you want and invent yourself or extend it. We use fragments, was it, for the geometry, and the schema behind could be anything, including IFC, of course.
Okay.
Yeah, I think it was a real good start with starting with the idea, what failed, and I really liked that part of it. I have this question about the rules that you are kind of trying to capture, like in the platform to build the new Revit. Is it like a recommendation, or would your AI or the platform will suggest that it may work, may not work? Do you see any challenges there from the?
I can try and answer.
Yeah.
Do you understand the question? You do?
Maybe, I don't know. I'll
Try
try.
it.
I'll try it. So the key point here is that the user is creating the tools that are intended for its project or whatever the scope is, and you have a test environment where you can test the tool. So you don't really do a tool and say, oh, it's good enough and publish it. No, you can try and test it. I think it was in the video. Oh, maybe I'll F11.
That was the question?
Yeah, I think it answers, because then you have something to test before you could apply it, right? Yeah.
Yeah, you are testing the tool before, so it's right here at the bottom. So you have like a test environment. And when you're satisfied with the tool, you bundle it and then share it with the marketplace where other users can like interact
Apply
with
it.
it and mature it if it's necessary.
Yeah.
What do you do when you're a team? So then you're a team now, so you develop this. But how, when you develop your tool all the time, how do you negotiate together? What is it seems like a social project as well, kind of.
The idea is that it's open, it can do whatever you want, so you can make whatever tools you want, and if they are combining, they are relevant for each other, then you just have a library where you put them together.
Next up is escape velocity. Escape velocity.
Yeah, so I guess a key part of why we all gathering in a place like here is to bring up new ideas to the industry and such, and try to implement them. And like we see now, you can have AIs wipe code entire solutions and such, but if you're trying to ask them for new ideas, often what you get is an Uber for X. It's a remixing of what we already have in the first place. A key reason for that is that let's see. Yeah. Essentially, a general aspect of how AIs are developed today is that they cannot escape their data training. A key part of what we are training large language models for is to converge towards the dataset. You can generate synthetic data that increases the quality of that, and that's where we see a lot of improvement is in the improvement of the data. But it still binds them to this area. So a way to do it is to essentially create more gravity wells that these AI tools can actually end up within. So instead of asking them for a new idea, and they struggle a bit with that, we essentially just seed them with new ideas, and we do that upstream. And a practice that I've been doing for the last 3 years is essentially just to think out loud. So when one of these ideas come up, I just talk out loud through the thinking process, record that, have AI transcribe it, which then automatically organizes into different topics, ideas, and that can then be hosted on data platforms like Snowflake, Hugging Face, Google Cloud. But companies can then buy these data packages. So essentially, they're just buying a zip file with a ton of data, but in the format that they can use for training AI models, or they can host it themselves through an MCP, so an AI can query in the exact data that's relevant. But the benefit is that for my use case here of expanding on these ideas, we practically already have AGI. We're discussing what is AGI, but for this particular use case, we reached AGI with GPT-4. That's way back. But essentially, if you hand an AI one of these core primitives, like an alternative to the wheel, which we'll get into soon, but then they can keep iterating on what are the implications of this, what would daily life look like. So we as humans don't actually need to spend that much time on this. We can essentially say, okay, what could be interesting to explore, and then have AIs do the heavy lifting of this. And because I'm recording the thinking process itself, we can actually copy one of the key aspects that have improved AI is the reasoning aspect. That means that we now have thinking AI models that to some degree think out loud before they're answering. And instead of just converging towards an answer, we actually train them to explore the opportunity space instead. Because when I'm doing this, I'm essentially just continuing to explore the space. And the AIs can then generate synthetic data from that process, which they can in turn study in the training process. So when you ideate with an AI, it will actually bring up these ideas instead of just trying to remix what's in the dataset already, because now it actually has ideas in the dataset already, and they will automatically emerge in the relevant context. You don't need to try to find product market fit and such. If someone says, okay, I'm at a workshop here for the AEC industry, we're trying to improve mobility in this area, then the AI can say, okay, I have some ideas related to this. And yeah, as we all know, the idea is the simple thing. It's the executions that are difficult. And my own database of this, where AI has expanded in the first degree of it, essentially mostly responding to what I've said and explore that a minimal bit. If you printed that out, stacked it up, you would get a 105 meters tall stack. It just shows the scale at what an individual can work at. And just a small sample, I had to make thousands of clusters to avoid random stuff being bundled together. Because when you don't have to bind yourself to what you're trying to solve immediately, you can just explore the entire space. So everything from society and civilization, interstellar communication, trade networks, economy and industry, housing, especially in terms of affordable housing, mobility, logistics, and yeah, plenty more. And under each of those, plenty of more subcategories. And yeah, one of the aspects here is the alternative to the wheel, and the building of buildings on top of each other, where we essentially keep building upwards, but we always start at the ground, which means that all of the ground here is displacing nature. And it also means that we need to build in the place that we're inhabiting, which means that when you build something here, you have to design for what's going to be the use case here. So you build something that's meant to be housing people, or you build an office space, etc., and then you cannot easily move it around. But here you could actually place the dwellings above farmland, and similar to power lines, you just have pylons from which you can create a mist between, and then you can essentially just relocate based on your current needs. And if it floods, it doesn't flood the building. You can have wetlands, and yeah, you can keep rearranging it. Then, yeah, I guess we're out of time. And yeah, if you need to adapt the space to your current needs, you can easily do that instead of getting locked into one place.
Nice. So you do also fly to your buildings then?
Yeah, so you could combine it with monorails and such. But actually, you could also use the suspension to get around. So, I don't. Yeah, there's plenty more in terms of that, and even that you could jump out the window to the next platform, so you don't need to go down the stairs. You could actually remove the hallways and such, and just enter directly.
You definitely foresaw the obvious question, kind of.
I think I'll take the next, maybe more conceptual question here. So I'm just curious to know what makes you think that AI might not think out of the box in the future?
In general, when of course, if we are going to, we are creating fundamental paradigm shift, so we are not utilizing large language models and such, which we hopefully will, because otherwise we're getting stuck here. But I don't see any reason why we shouldn't contribute new ideas, because if we cannot contribute new ideas, where does that leave humanity in terms of the economic model? If AIs can think all the things that we could ever think, we might be struggling a bit for where do we actually fit into this. And when we already have the large language models today that perfectly understand these things, I don't see why we don't collect all the ideas that we have here already. If people could get compensated for that, the thousands of ideas that die in a place like this because you cannot pursue them, or that are delayed years or decades because it takes time to execute, we could capture those.
Yeah. And have you built anything over the weekend for this?
Yeah, so I've built an MCP for this. I don't know if I can. Do we have time to?
We have 1 minute and 15 seconds.
Okay, maybe I can run it in the background then. Okay, so we are currently at a hackathon for the AEC industry. Can you use the MCP to find or figure out some ideas for how we might improve transport in the cities? So now it will be fetching the MCP that I've set up with where it looks through the available data to it, the different categories, a short description of the individual concepts. It should allow it to now look through an idea catalog instead of just trying to synthesize something on the fly, which typically just leads to these repetitive things where, because the training data that we have is practically just what's already on the market, what's already well described. Whereas here, I'm bringing in novel concepts that allows them to now bring up these ideas in the relevant context.
All right.
Next group is bridge the gap, which is the previous city gap. The last presentation. After this presentation, the jury will withdraw, do the evaluation, and we will start the award ceremony at 5 o'clock.
So it's half an hour earlier.
Half an hour earlier. We have gained 30 minutes.
Hi, I'm Kirtana. I'm a computational designer.
And I'm Niklas, and I'm like a bridge engineer.
Our colleague Diana was under the weather this afternoon, but she contributed with her background in urban planning. We arrived at the hackathon as a clean slate, and we were quite inspired by the pitch from Henning Larsen, where they discussed the importance of the city and the different layers of data and the interaction. And we could not help but look at it from the lens of footbridges, particularly because we have one of the most iconic footbridges right across the street. When you think about these structures, they're such important part of the urban fabric, whether it prefers the cyclists or the pedestrians to pause, move, or does it isolate the pedestrian from what's happening in the surroundings, or is it simply an equal shared space and it's an interaction with the environment and the different junctions. So we, to confirm this curiosity, we took a stroll around the city, and with a vision language model, we were trying to just see if there were patterns about the movement that happens over and under and around the bridge, and people in their different methods of movement. And this is not just constrained to where the bridge is located, but just riding down the city on a bike, you have these moments where you feel anxious, or you're slowing down, or if you go over the cyclosanga, you actually feel like you have a priority over the pedestrians and you're zapping through as a cyclist.
Yeah, and as we saw in the video, we went out to test like how different bridge alignments or different bridge designs influence the behavior of the cyclist or the pedestrians, and how we know, at least from our career, how bridge designs are started nowadays. We have all this information somewhere available, and it was also mentioned in a lot of the other presentations. But the issue is it's in a lot of different formats. Like some of it is a PDF in a design brief. A lot of it is like is point clouds, for example. And our mission was to make the data more tangible and make it inform our bridge design for the alignment, basically. And to test our framework that we developed here over the weekend, we chose like a site in Germany, which is actually a site where a bridge is going to be built. It's somewhere outside of Mannheim. There's not much going on. And here on the right we also saw the design brief. And then we used, we could try to convert the data that was available as heat maps that we could display as different layers for the user with different, here the traffic flow and different kind of data. And then the demo we made on this specific site was then you project it on a screen, and then you can turn on and off the different layers, take information from that. And for your bridge design, you just sketch the bridge on the paper, on the board, and you also enter important geometric information as like the desired slope you want to have, and also the radius, which then determines the clearance and how the bridge will affect the pedestrian behavior. And then you sketch it, you sketch your geometric data, and then it converts over to a geometrical model, and then you can run your simulation here based on a cyclist, that based on the slope and the radius of the bridge, it will slow down or speed up in the end.
So this is just an interactive test we wanted to run if you had all these different data sets in a sort of cohesive visual format. So you can really filter through the information, understand the correlation, and remove the noise. And so the designer has this decision making in their fingertips in a visual manner, and it seamlessly integrates into your existing design workflows, whether iPad or HandSketch or in your CAD software. So for the backend, all of which we developed in this weekend, we translate the sketches using vision language models to have a spatial recognition of the sketch, and computer vision to map that back. So the percentages, like the 3 or 4% of the slope, gets updated, extracted into a JSON, and then a Rhino API geometry is just computing this to get the slope, which then interacts with your the simulation that you want to test. And for the data, we were using primarily the design brief, which comes as largely text, Excel, and CAD files. It was so interesting to see how the vision language model was able to map all this text information back into the CAD file, which is what we used primarily to get these space maps on the spatial information. Google Earth and also different bridge design manuals. And we were very interested in trying to work with the data from Infrared City. But since we were constrained with a specific site, there wasn't so much information in this specific location that we could get. And we just passed the data around as JSON files, and everything lived as a script that we just ran through VS Code. And of course, some of which was wipe coded, and there was Gemini was primarily used as the vision language model. And of course, more low-tech solutions like a sketchboard and paper, and and the data just passed around as JSON files. So if you ask us, we wouldn't call this an app or a software. As designers, this is just a sort of a interactive visualization framework that allows to see your different sources of data, whether it's from your client or whether it's from open source information, cohesively, and to enable you to interact with it seamlessly in your CAD software of choice, and not have to necessarily worry about interfaces, licensing, interoperability, because as a designer, you just want to have that flow in an interaction in a few milliseconds. And that's what we wanted to focus on today and try to explore with Bridge the Gap.
Could you quickly exemplify how the data from the brief, etc., was used in your design? So far I've seen that you kind of draw a route, but then there is other information coming in.
Sorry, into the heat map? Was it this one?
Generally, how data informs the design was my question.
Oh, for bridges specifically, you would look in, it depends on the context. So in this specific case, it's over a road bridge. So it depends on the neighborhoods that you're connecting. Do you want the pedestrians to move rather quickly or take a pause? Maybe if it were over a scenic view like a river, you might have a more meandering route, but it really depends on the context, the areas that you're connecting, the junctions, and also the larger sort of future plan and how it connects with the network in that location.
Yeah, maybe also if you have like, if you want to connect like a cycling network, where there's like a, I don't know, a speed cycling highway that is used for like a lot of people that need to go to work, like forth and back. It's important also for the type of bridge you choose and the type of alignment that it doesn't slow people down, but it should enable people to keep the same speed. And that was the thought behind it. But there's still some work to do on how the data changes if we change our bridge design, which was a bit a tricky one to solve in the weekends.
All right. So, how much did you build during this weekend, and what did you have like before?
We built nearly everything this weekend.
And of course we used AI to get some of the code, but everything was done. We came as a clean slate concept.
Okay. Yeah. Thanks.
So let's give a round of applause to all of the presentations. Amazing. Amazing. I mean, it's really amazing what has been created during the weekend. So the jury will now redraw and do their voting, and in 30 minutes we will announce the winners at the award ceremony. So 30 minutes break. We start again at 5 o'clock. So go grab something to drink, and the jury will withdraw. And I hope that you enjoyed the presentations. Thank you.
I was gonna say with the 34 cities, yeah, was that it? But I don't remember. And then we just get started, and then we say ours. No, then we say that the community is the best.
Yeah.
And then it's our fun fact.
That would be.
That was the mini, and then it goes to the juries, and they want to say.
So the jury. Good.
So they want.
Okay. But then let them do that.
Yeah.
So
Are we ready? All right. Thank you so much for a really, really, really nice weekend. I had so much fun with all of you. I wanted to say it's been so much fun. I'm going to miss you on Monday. I will not be happy when you're not in the hallways anymore. So I remember when I ran around earlier and asked where we're all from. That was fun. We're from 34 different countries. And then the one little thing that Torben and we had a little connection moment when we invented a new category. Because there was one team that had the most amazing timing, and you presented for exactly 7 minutes, and that was magnificent for me. So, Claudius, spoiler, Claudius. I forgot. And because it was a surprise category, I only have a little chocolate for you guys. But you had amazing timing. No, the small one. There you go.
Thank you.
You're welcome. And I think we quickly take a picture.
Yeah.
Okay, great. And then we had another winner that is all of us, the community. And I think now we get to the serious stuff, right? Should I hand over the mic to you, or do you want me to announce it? Okay. Do you know the...
You know.
No, that's the right order. Yeah.
All right.
Yes.
Should we start now with?
Yeah.
Okay, so really.
Martin, so that we are in the camera.
Yeah, in the camera.
Okay. Yes.
Do I need a microphone?
Yes. Yeah.
I can get rid of this, but it's also really nice. So thank you very much. It's been a super honor to be here and to see all the really amazing ideas. It's amazing what you can come up with in 2 days. It's also cool if you come prepared and have like something in your backlog that you can unfold today. So I think it's also highly appreciated to see all companies from Ukraine or Poland or wherever pitch in ideas. I think we really like that. Although we also really kind of value the effort that you put in this weekend. So and that was quite amazing. So should we start with?
Yeah. We have an honorable mention, and that goes to Bridge the Gap. Would you like to come? Yeah. And it was a really good project and idea. And of course, we also had to consider the impact and a couple of the parameters, but it was a really well-deserved project as such. Yeah.
Thank you very much. And we also have to say really nice to what we also really wanted to kind of honor is like your step from data analysis to like your own data to design. Thing like this span was not in all the projects, so that's why you get a really honorable mention. Thank you very much.
Thank you.
Yeah. Okay.
Allow me to stamp the feet before you say the name, okay? And
Yes.
The winner is, and then everyone
Stamps and feet. Cool. I'll do that. Then we have the best mashup project. And the winner is Cities We Deserve.
So thank you very much. I think there were a lot of projects who really answered the challenge, and I think we thought you did it in a very nice way. Also very homebrew way, obviously, and like the game idea really good, and also like that you step beyond visualization into something where you can actually start to analyze and simulate and get different agents together. So thank you very much.
Yeah.
So next one is the biggest of them all. It's like best solves a big problem category. All right. And that is repurpose DK. Yes, hello. Come on, hey! Thank you very much. We think like circularity and reuse and how to get this into the world is really, really big problem. It's also really a hard problem, and so any contribution is really great. And you did a very good contribution. Thank you very much.
Thank you. The next one is best hack for humans. And let's see who has hacked it. It's Quad LM. Quad LM. Or the city rat.
I didn't know what was the name of
Yeah, you got yours already here, kind of. Thank you very much. So really great. Also, again, like for the extra purpose of putting simulation into the layer and then being able to maybe ask very personal questions like, does my dog get wet when I'm going jogging this morning? So I think like this kind of multi-layer, different data and generating your own data was highly appreciated. Yeah.
Thank you so much.
Yeah. So now we come to the category best overall project. Oh, yes. And it is a one-man show, Sublayer. Congrats.
Sublayer.
Yay! We don't understand why nobody wanted to join you, because maybe there should have been some.
Coming here for a photo.
But it's we saw. Okay, thank you very much. And then the category with the most potential, the best startup project. Ooh! Clash Hero, come up.
Class Hero.
Yes, okay, great. So, so amazing to ask why doesn't this still exist or already exist? Or hopefully it works out for you guys. You know.
So, we done?
First and foremost, I think before you leave the stage, please, the jury, and Timu, who had to take a flight back to Helsinki. Thank you so much for your presence today. So I think a big round of applause for the 3 judges. Thank you so much for taking part. Again. Sorry?
You need to go backwards. We jumped a slide, but I can do it. Should I just go?
So, yeah, please. We are coming to a close now. I hope you have enjoyed yourself throughout the weekend. I hope you think that we have supported you. We have tried to support you the best way we could in doing this event again, the 8th time, as I think I said on Friday evening. I would love to have Cecilia on board the stage, because I would like you to give a big hand of applause to Cecilia, our event manager.
Frida and Mariam also.
Sorry?
Frida and Mariam.
And Frida and Mariam also, please come up on stage. And Vigga. Anyone else? This is the whole team supporting you this weekend. Lisa, Michael, Cecilia, and our service staff. Give them, woo! Thank you so much. Thank you so much. And to you, of course, thanks for taking your time out. I know I was just doing a little bit of a reflection here this afternoon, because I know that we this year we chose a date, a horrendous date, because we are halfway into the Easter, right? And also you had 1 hour of sleep less last night. And I'm so sorry. There's only one guy to point at. That's me. Sorry. I'm never ever going to do that again. Of course, we're going to do this again next year. We haven't got a date yet, because we are really contemplating. Maybe we should use some AI bots in looking at all the different conference calendars, etc., across the world. But we will come up with a date very, very soon. Just a very, very few closing remarks. All the winners this year, of course, it's you, but the ones actually been given the prizes you've just seen will also receive, as part of the prize, a 1-year membership of BlocksHub. So those of you who have won today, you are now, and until the end of this year, officially members of BlocksHub. So you can access our co-working space every day if you want. You can come and go, you can join our activities, whatever you want. So thank you for that, and I hope you'll join us in the community going forward as such. The rest of you, of course, will also be online members, because you joined. Was it Square? Lisa, what was the name? I think, yeah. You mentioned that only once on Friday evening, yeah, right? No, you have joined Square now, and as joining Square, you will automatically be online members of BlocksHub for the rest of 2026. And then you will know about the next hackathon. Yeah, so we will, of course, release the dates in due course on the platform. So please log on the platform. All the presentations and everything that goes with it is on there, all the different activities. If you are in Copenhagen, if you are around here, please come to BlocksHub, access the activities, take part, etc., etc. If not, of course, you have to access online instead. But having said that, there is one last note on my agenda. We said on Friday night that if any of you would like to take your developments further, please come back to us, because the partnership around the event, the hackathon event, BlocksHub, RIB, Contact Lab, Ramble, Henning Larsen, PropTech, and We Build Denmark will do anything in our powers to help you, to boost you into the primarily Danish industry, but as much as possible also the international construction industry. So if you're interested in talking to us, whether you can take your solutions beyond what you have developed this weekend, then come back to us. And on a practical note, come back to me. This is my email, tkl@blockshub.org, and then we will set up an online meeting or a physical meeting here in BlocksHub discussing how can we take your solution further, depending on what you want. You are the ones that knows what the solution is about. You are the ones that knows what would you like to make out of that solution you've created, either wholly or partly throughout this weekend. So, you know, we can push the industry bringing all the different resources together in our partnership network. Are you interested in doing debates or workshops or marketing your solutions or whatever? Are you interested in getting closer to funding for your solutions, etc., etc.? There has been several earlier hacks that actually obtained funding after the event here, if you want to do that. But it's entirely up to you. So this is just an offer we invite you to, but you are not at all supposed to do that if you don't want to. You might just have had a fun weekend, meeting lots of great people, learning lots of new stuff. That's the prime purpose of any AEC Hackathon. Damon Hernandez, my good colleague, nods, so you know that's right. Not only when I'm saying it, but when he nods, then it's right, right? So, coming to a close here, thank you so much for having attended. Yeah, please, thanks. Last, but at all not least, to our sponsors. So again, a last round of applause to our sponsors, without whom we could not do this. RIP, Ramble, Webuild Denmark, Contact Lab, Henning Larsen and PropTech Denmark. Thank you so much. Sorry? There's one more slide. Okay, yeah, let's have that. Yeah, of course. I want to, of course, also, thank you so much, Lisa. Thank you, Matthew, for your podcast yesterday. Without that, the Saturday afternoon would have been quite dull, I think. So that was great. It was a great way to boost the discussion and the debate within the construction industry and all the varieties of different applications of tech. Thank you so much for that map. And a big round of applause to Matt, from all of you to Matt, please. Before I hand the mic over to you, saying the very, very final note, I would like one man to get up here, please. Damon Hernandez. A big round of applause to Damon as well. Without whom we couldn't even spell to AEC Hackathon. Great stuff, great stuff. Thank you all from me. Thanks for BlockSup. Thank you from the team. I hope you'll be back sometime next year, round about the same time, but no, not close to Easter, and no, you'll get an extra hour next year if we're even close to that date. So thank you so much for turning up in Copenhagen. Thank you all. Thanks for the team. Thank you from me. Thank you all.
I just wanted to put the QR code for LinkedIn for BlockSup on the screen so you can see what other fun events we have. We have really, really cool initiatives. Our team works really hard on a lot of interesting areas of the built environment, and I think a lot of you could benefit. I saw you looking through our books, and we have publication events. We have so many fun things in-house. So scan the QR code.
Stay tuned on the date
for the next time. Woo!
Thank you so much.
And we have refreshments now. And bubbles. Congrats.